Imagine a river that does not carry water, but meaning, a current not of matter, but of relation. Every point of the river depends on another. Every ripple speaks to the next. Such a flow does not move through space. It creates space as it moves. This is not a metaphor only for beauty. It may be the truest description of the universe itself. When we look out into the cosmos, we see vast structures that seem still, yet they are in motion. Galaxies drift through the cosmic sea at hundreds of thousands of kilometers per second. Clusters twist around one another. Filaments stretch like glowing veins through a body of darkness. Even the great emptiness between stars hums faintly with motion. Space-time itself expands, pulling galaxies apart like specks in a rising tide. On large scales, the universe behaves as a fluid, turbulent, continuous, and alive with motion. But beneath that visible motion lies something deeper. Physics tells us that every galaxy, every atom, every fluctuation of light is part of a grander flow, a hidden current of information. The word information might sound cold, mechanical, yet in modern physics, it carries the warmth of reality itself. Information is not just about messages or symbols. It is what defines the difference between one state of the universe and another. Every wave, every quantum, every vibration of space carries information about how reality is arranged. In the early 20th century, we thought the universe was built of particles, small, indivisible bricks of matter following predictable rules. Then came quantum physics, which showed that these bricks were not solid at all. They were waves, probabilities, patterns of information in constant motion. When one particle affects another, what actually passes between them is not a physical piece of matter, but an informational relationship, a correlation that ties their fates together. In this picture, reality begins to look less like a machine and more like a fluid. Every measurement, every event is a small swirl in a continuous field of relationships. Nothing stands alone. The universe is an ocean of interactions, each shaping and being shaped by the rest. Consider the equations that describe ordinary fluids: water in a river, air in a storm, plasma in a star. They are built around continuity, the idea that what flows into one region must flow out of another. Nothing is lost, only transformed. In quantum mechanics, a similar rule applies. The evolution of a quantum state is unitary, meaning that information cannot vanish, only change its form. The conservation of information in quantum physics is the echo of the conservation of mass and energy in hydrodynamics. This strange mirroring has led physicists to a remarkable idea. Perhaps the deepest structure of reality behaves not like a solid foundation, but like a fluid that carries information through time. The equations that describe fluid motion might not be metaphors for quantum behavior. They might be cousins, born from the same hidden principle. Picture space-time as a vast ocean with no shore. Its surface ripples with waves that we call light. Its depths twist with vortices we call black holes. And beneath it all, unseen, flows a river of entanglement. Quantum connections that tie distant regions together as if space itself were woven from invisible threads. These threads transmit not energy or matter, but the raw structure of relationship. On human scales, we think of flow as something that happens in space, a breeze through the air, a current through water. But if space itself is born from quantum relationships, then flow must happen beneath space. Or perhaps it is space. This is the radical thought at the heart of modern physics, that geometry, distance, and even time may be emergent, the visible patterns left behind by the unseen movement of entanglement. Imagine pouring dye into a glass of water. At first, the color threads out in delicate tendrils. Then turbulence begins, and the dye spreads, mixing until every molecule of water carries its hue. Something similar happens in quantum systems. A particle interacts, and its information begins to spread. At first, it is localized, but then it diffuses, entangling with countless others until its identity dissolves into the collective whole. If we could see this process, it might look like colored smoke folding into invisible wind. What we call the evolution of a quantum state could be the most intricate form of turbulence imaginable, a storm not of matter, but of information. The laws of hydrodynamics emerge whenever a system becomes too complex to describe particle by particle. The same happens in quantum physics. When the interactions become overwhelming, when entanglement spreads beyond our ability to track it, we find that the system behaves collectively, as though it were a single fluid. This is not coincidence. It may be a clue. In this light, the universe at every scale, from quark to galaxy, may obey one unifying principle. The flow of information tends toward collective behavior. Just as water finds the path of least resistance, so does information find the path of least complexity. And when that happens, hydrodynamics appears, not as an approximation, but as the natural language of reality. From the quiet hum of atoms to the cosmic rivers of galaxies, everything flows. The only difference is what kind of information the flow carries. In stars, it is energy and plasma. In human minds, it is thought and memory. In spacetime itself, it is entanglement, the invisible connective tissue that allows one region of the universe to know another. The more scientists probe the quantum world, the more it begins to resemble a dynamic sea. Experiments with ultra-cold atoms, superconductors, and quantum computers reveal patterns that echo the movement of fluids. Waves of entanglement that propagate, interfere, and even form shocks and vortices. The mathematics of these systems mirrors the mathematics of flow. And if this is true at the smallest scales, what does it say about the largest? Could the same hidden current that stirs electrons also shape galaxies? Could the expansion of the cosmos itself be a kind of informational tide, driven by the spreading of quantum relationships across the fabric of reality? As we follow this idea, the boundary between matter and information, between particle and wave, between structure and flow, begins to dissolve. What remains is a vision of the universe as a living continuum, a ceaseless motion of relations giving rise to everything we see. And so we arrive at the question that will guide our journey through this book. What if the deepest laws of the universe are not written in the language of particles, but in the hydrodynamics of entanglement, the continuous, collective motion of information itself? To understand what it means for information to flow, we must first understand what information truly is. In the world of physics, information is not a human invention. It is the very structure of possibility itself. Every particle, every field, every configuration of energy holds a certain amount of information, a measure of how distinct it is from all other possible configurations. The more precisely you can describe a system, the more information you possess about it. But nature does not allow infinite precision. Quantum mechanics draws a boundary around what can be known. That boundary, curiously, behaves like the surface of a moving fluid. When physicists describe quantum systems, they use a mathematical object called a wave function. It is a vast and delicate entity that encodes all possible states of the system at once. As time passes, this wave function does not jump from one state to another. It flows smoothly, continuously, governed by the Schrödinger equation. This law tells us that the evolution of a quantum system conserves information just as the flow of a river conserves water. Nothing is lost. What changes is the pattern of relationships, the distribution of probabilities, the way one region of the system becomes correlated with another. In this view, reality itself is an unbroken stream of transformation. The universe does not tick forward like the gears of a machine. It unfurls, one state giving birth to the next, in a constant current of evolution. Every interaction is a ripple in this current. Every measurement, every observation is a small eddy where information gathers and disperses again. Now imagine scaling this idea up. Suppose you could watch the universe as an ocean of pure quantum information. You would see waves of entanglement spreading across it, braiding together distant points, forming patterns that stretch across light years. These waves would not move through space. They would create the sense of space by connecting what we think of as separate regions. This is not mere speculation. The mathematics of quantum field theory already hints at this behavior. Fields do not live in space. They are space, vibrating with energy and correlation. When these fields entangle, they generate structure. Where the entanglement is dense, geometry becomes curved, giving rise to what we perceive as gravity. Where the entanglement is uniform, geometry appears flat and calm. The geometry of space-time may therefore be nothing more than the large-scale expression of how quantum information is arranged and how it flows. It is in this sense that physicists have begun to speak of the hydrodynamics of entanglement. They mean that the collective motion of quantum information follows patterns familiar from the study of fluids: continuity, diffusion, turbulence, and flow. At first, this language was metaphorical, but the more scientists explored, the more precise the analogy became. Equations from fluid mechanics began to appear naturally in the description of quantum systems. In some experiments, cold atomic gases displayed waves of entanglement that propagated exactly like sound waves in air. In others, chaotic quantum systems showed signs of viscosity and flow resistance, as though information itself were a tangible fluid. One of the most remarkable discoveries came from the study of black holes. When theoretical physicists applied the mathematics of quantum field theory to black hole horizons, they found that the event horizon behaves like a fluid membrane. It has temperature, pressure, and even viscosity. The motion of this horizon fluid encodes how information flows into and out of the black hole. What was once a mystery, how black holes process and emit information, began to look like a problem in hydrodynamics. The boundary of the black hole acts like a cosmic river surface, where quantum information swirls, stretches, and eventually radiates away as faint Hawking radiation. This connection between the quantum and the fluid is not limited to black holes. It appears wherever information becomes dense and interactions become strong. In quark-gluon plasmas, the hot, dense matter created in high-energy collisions, physicists found that the fluid's viscosity reaches an absolute minimum, a limit set by the quantum of action itself. It is as though there is a universal rule. When systems reach the extreme of correlation, they flow with perfect smoothness. If space-time itself is born from quantum correlations, then perhaps it too behaves like such a perfect fluid. The curvature of space could correspond to the gradients of information flow, while gravitational waves might be the ripples of that flow spreading through the fabric of reality. This would mean that gravity is not a fundamental force, but a macroscopic effect, the way the fluid of entanglement responds when its density changes. Imagine you are floating in this invisible ocean. Around you, invisible currents push and pull. They do not carry matter, but meaning, the connective structure that makes events possible. Each atom of your body is a vortex in this current, shaped by the flow of entanglement with the rest of the universe. When you move, you do not travel through space-time. You disturb it, sending waves through the sea of information that binds everything together. This picture reshapes our intuition. The cosmos is not a static stage upon which things happen. It is a self-moving continuum whose only constant is motion itself. Even what we call emptiness is not empty. The vacuum of space is a seething field of virtual activity, a froth of entanglement that never comes to rest. When you strip away matter, energy, and even light, what remains is pure information, and it never stands still. The hydrodynamics of entanglement suggests that what we perceive as the solidity of matter is simply the stability of flow. Like whirlpools in a river, particles persist not because they are made of something, but because the flow that defines them maintains its form. The laws of physics then become rules of stability, describing how patterns in the information current endure, interact, and sometimes dissolve. There is beauty in this vision. It unites the restless quantum realm with the serene cosmic order. It tells us that the same equations that describe clouds forming on Earth may also describe galaxies forming in space, and perhaps even the emergence of space-time itself. The difference is only scale, not kind. And yet, one question rises like a silent undertow beneath it all. If reality is a flow of information, what sets it in motion? What is the source of the current that never stops? The reason that existence moves rather than freezes? To answer that, we must look deeper into the nature of entanglement itself, into the hidden connectivity that binds the cosmos into one continuous whole. Entanglement is not merely a curiosity of the quantum world, it is the deep grammar by which the universe speaks itself into being. When two particles interact, they do not simply exchange energy and part ways. They become linked in a subtle way that transcends distance. Each particle carries a record of its connection, and that record cannot be erased. Measure one, and the other responds instantly, no matter how far apart they have drifted. This is the essence of quantum entanglement, and it defies our ordinary notion of space and time. To grasp its meaning, imagine a lake at dawn, perfectly still. Drop two stones into it at different places. The ripples expand and intersect, creating a pattern of interference that belongs to neither stone alone. You could no longer describe the ripples by referring to each stone separately. The pattern exists only as a whole. This is what entanglement does to reality. It weaves separate events into a single fabric of correlation, one that extends across the universe. Physicists once called this spooky action at a distance, a phrase born from unease. It seemed impossible that two objects could share a state instantly, violating the speed limit set by light. Yet experiment after experiment proved that this connection is real. The key lies in understanding that information is not traveling between the particles. Rather, the particles never truly separated in the first place. They remain part of one larger wave of information that spans them both. What we perceive as distance is only an illusion born from our limited viewpoint within the flow. This realization transforms how we think about space itself. If entanglement binds distant regions into one continuous whole, then the geometry of the universe is not fundamental. It is emergent, like the shape of a river that forms naturally from the movement of water. Entanglement defines adjacency. Where correlations are strong, regions of space appear close. Where correlations are weak, they seem far apart. The map of the cosmos may therefore be drawn not by measuring distances, but by charting the strength of informational currents between its parts. In this sense, space-time behaves like a fabric woven from threads of entanglement. When the threads tighten, curvature appears, what we call gravity. When they relax, space flattens. The dynamic geometry of the universe is the texture of this weaving, always changing, always flowing. Consider the early universe, moments after the Big Bang. It was not filled with particles, but with overlapping waves of quantum fields, entangled across all directions. As the universe expanded, these correlations stretched and evolved, creating the seeds of structure we see today: galaxies, stars, and worlds. The cosmic microwave background, that faint afterglow still bathing the sky, is a fossilized image of these entanglement patterns frozen in time. Its ripples are not random. They are the imprints of quantum information that once surged through the newborn cosmos like waves through a boundless sea. The notion that information flow shapes reality leads to profound consequences. It suggests that every physical law, every apparent constant, may be the large-scale reflection of simple principles of information balance: continuity, conservation, and flow. Just as water seeks equilibrium through motion, information does too. It moves until correlations even out, until entropy stabilizes. What we experience as time may simply be the unfolding of this drive toward informational equilibrium, the constant rearrangement of connections across the fabric of existence. Even consciousness, when viewed through this lens, becomes a local eddy in the cosmic current. The firing of neurons, the emergence of awareness, the feeling of thought moving, all are flows of information through biological matter. The difference between a human brain and a galaxy may be one of scale, not principle. Both are organized streams of entanglement. self-reflecting structures within the grand continuum. If one could step outside the flow and look down upon the universe as a whole, there would be no static picture, no frozen snapshot of being. There would only be motion, not motion through something, but motion as something. The universe does not exist and then move. It exists because it moves. Flow is not an effect of creation. It is creation itself. When fluid dynamicists study turbulence, they find that small eddies feed into larger ones, transferring energy across scales. A similar cascade may occur in the hydrodynamics of entanglement. Quantum fluctuations at the tiniest scales may generate patterns that influence larger and larger structures, building the hierarchy of the universe. From quarks to stars, from atoms to galaxies, the same informational cascade could be unfolding, layer upon layer. What we call order may simply be the persistence of certain patterns within that cascade. Like whirlpools in a vast river, stable forms of flow endure for a time before dissolving back into the current. Stars are whirlpools of plasma, planets whirlpools of dust, life a whirlpool of chemistry, thought a whirlpool of memory. Each holds its form only because the flow sustains it. When the flow changes, the form fades, yet the information is never truly lost. It disperses, rejoining the greater movement from which it came. The hydrodynamics of entanglement paints a universe without true boundaries. There are no isolated systems, no perfect vacuums, no separate things, only varying densities of connection. Even in the deepest void between galaxies, the quantum vacuum seethes with correlations. Space, in its quietest form, is still humming with invisible relationships. This vision does not reduce the universe to abstraction. It deepens it. To say that everything is information is not to strip away mystery, but to reveal that the mystery lies in relation itself. The world is not built of things, but of the ways things intertwine. As physicists continue to map these flows, a new picture of the cosmos emerges, one in which the laws of gravity, thermodynamics, and quantum mechanics are all facets of a single principle, that information moves, and that movement is what we call reality. When we gaze at the night sky, we are not looking into emptiness. We are looking into the current itself, the great invisible tide of entanglement that binds all existence together. Every star, every atom, every flicker of thought is a crest in that tide. The universe does not rest. It never has. Beneath all silence, beneath all stillness, beneath every illusion of separation, there is only the flow. And so we close this first chapter where we began, at the edge of a river. But now we know it is not water that moves before us. It is the fundamental current of being, the unseen motion that shapes worlds and carries time. As we step forward, we follow that current deeper to learn what it truly means for the universe to be woven not from matter, but from the hydrodynamics of entanglement. To understand the hidden architecture of the universe, we must confront one of the most counterintuitive truths ever discovered, that separation is an illusion. Quantum entanglement is the quiet rebellion against our common sense, the proof that reality is not built from isolated pieces, but from relationships that transcend distance and time. It is the thread that weaves the cosmos into one indivisible whole. Long before the word entanglement entered physics, the world was imagined as a collection of parts. Atoms were tiny marbles in empty space, colliding and rebounding according to clear rules. But when scientists began to peer into the heart of the atom, this picture shattered. Electrons did not move in predictable orbits like planets around the sun. They existed as clouds of possibility, as shimmering probabilities that only took form when measured. The deeper we looked, the less we found solidity, and the more we found connection. In the early 20th century, a new framework emerged to describe this strange behavior. It was called quantum mechanics, and its equations describe particles as waves of information rather than hard points of matter. These waves could overlap, interfere, and most mysteriously of all, become entangled. When two quantum systems interact, their wave functions merge into one. From that moment on, their properties can no longer be described independently. Measure one, and you instantly know something about the other, no matter how far apart they are. Albert Einstein found this deeply unsettling. He called it spooky action at a distance, believing that there must be some hidden variables at work, secret signals traveling faster than light to coordinate the outcomes. But decades of precise experiments have shown otherwise. There are no hidden signals. The connection is real, immediate, and built into the foundation of reality itself. To grasp what this means, imagine a pair of dancers who begin in perfect synchronization. Even if one travels to a distant world and the other remains on Earth, their steps remain correlated, not because they send messages, but because the dance itself extends across space. The choreography is shared. In quantum mechanics, this choreography is written into the mathematics of the wave function. It is not an after-effect of motion, but the original condition of existence. Entanglement shows us that information does not obey the boundaries we draw between objects. When two systems become entangled, they stop being two systems at all. They become one system described by a single state. The universe, at its most fundamental level, may be just such a single entangled state. A web of correlations extending from one end of creation to the other. The measure of this connection is called entanglement entropy. It tells us how much information is shared between regions of a system, how deeply one part knows about another. This measure behaves in ways that mimic the laws of thermodynamics. It increases with complexity, spreads with interaction, and reaches equilibrium like heat flowing through matter. When physicists plot how entanglement entropy changes in time, they see curves that look uncannily like the flow of energy in a fluid. This resemblance is not poetic coincidence. It is the first hint that entanglement might obey its own form of hydrodynamics, that the motion of information through the quantum world follows patterns of flow, diffusion, and balance. Where heat diffuses through matter, entanglement diffuses through correlations. Where viscosity resists motion in a fluid, decoherence resists the spread of pure quantum information. The same mathematics describes both. Experiments with quantum computers and ultra-cold atoms have confirmed these behaviors. When physicists entangle long chains of atoms and watch how the information spreads, they find that it does not leap instantaneously. It flows outward, forming wavefronts of correlation that move with a finite velocity, much like ripples spreading in water. This entanglement velocity sets a limit on how fast quantum information can move, just as the speed of sound limits how fast disturbances travel through air. At the scale of the cosmos, such flows could define the architecture of reality itself. Imagine the universe at its birth, a sea of entangled fields, every quantum connected with every other. As expansion stretched the fabric of spacetime, those connections began to rearrange, forming gradients of correlation that we now perceive as geometry. In that sense, spacetime may not merely host entanglement. It may be entanglement, frozen into a particular configuration. We see its fingerprints everywhere. The cosmic microwave background, the oldest light in existence, bears patterns that trace the quantum fluctuations from which all structure grew. These fluctuations were entangled across vast distances, their correlations imprinted in the faint ripples of temperature we detect today. Every galaxy, every cluster, every star is a crystallized echo of those ancient quantum relationships. Even black holes, those most mysterious of cosmic objects, whisper the same truth. The amount of information they contain is not proportional to their volume, but to their surface area. This means that what happens inside a black hole is somehow encoded on its boundary, a profound hint that information and geometry are two sides of the same coin. Entanglement builds both. What we call space is therefore not empty. It is a network of invisible relationships, a shimmering mesh of correlations that hold reality together. The more deeply we examine it, the more it behaves like a living fabric, flexing, stretching, and rippling in response to the flow of information within it. But this insight carries a challenge. If entanglement connects everything, why does the world appear so separate? Why do we see individual objects, isolated stars, distinct moments in time? The answer lies in the limits of observation. When we look at a system, we only ever see a fragment of the full wave of reality. The rest becomes part of what we call the environment. In doing so, we break the seamless whole into pieces, trading unity for clarity. This process, known as decoherence, hides the flow of entanglement from our senses. It creates the illusion of classical reality, where things have definite positions and independent identities. But beneath that illusion, the connectivity remains. The universe never truly separates. It only appears to when viewed through the narrow window of limited knowledge. Thus, the hidden connectivity of the cosmos is not a metaphor. It is the fundamental architecture of existence, a structure built not from atoms, but from relationships. The more we learn about it, the more we see that everything from subatomic interactions to cosmic evolution is an expression of the same underlying principle, that the universe is a web of entanglement, flowing, expanding, and transforming in a perpetual dance of information. When we speak of entanglement, it is easy to imagine it as something static, a connection frozen between two particles, a hidden thread binding them in silence. But entanglement is not still. It moves, it evolves, it spreads like heat through metal or ripples through water. The universe is not merely stitched together by entanglement, it is animated by its motion. This hidden dynamism is what physicists have begun to call the flow of quantum information, and it may be the deepest current running through existence. To understand this motion, imagine a row of atoms in a laboratory, suspended in a vacuum and cooled almost to absolute zero. In that cold stillness, the atoms barely move, and their quantum states can be controlled with exquisite precision. When a pulse of light entangles the first atom with its neighbor, something begins to happen. The correlation does not remain between the pair. It propagates outward, like dye in water, linking atom after atom as it goes. The rate at which this happens is measurable, and what emerges looks astonishingly like a wavefront. Entanglement spreads through the chain with a well-defined speed, leaving behind a growing region of shared information. This is not the movement of energy or matter, it is the movement of correlation. What flows is not substance, but knowledge, the mutual awareness that parts of a system have of one another. This flow obeys laws of continuity and conservation, just like the laws that govern fluids. Where correlations increase in one region, they must decrease elsewhere. The total informational content remains constant, even as it rearranges its form. In this way, quantum systems display a hidden kind of hydrodynamics, a subtle current of meaning moving beneath the surface of physical motion. The mathematics that describes this process mirrors the equations used to describe ordinary fluids. There is an informational density that can vary from point to point, an informational current that describes how it changes in time, and even something akin to pressure. A tendency for regions of high entanglement to spread into regions of low entanglement until balance is restored. When systems are driven out of equilibrium, these flows can become turbulent, creating patterns of quantum chaos that look strikingly similar to the swirling vortices seen in smoke or water. Such parallels are not coincidence. The deeper physicists explore, the more clearly they find that the equations of hydrodynamics are universal. They emerge whenever a system is too complex to describe in detail, yet still obeys basic conservation laws. Whether we study a droplet of water, a plasma of charged particles, or a quantum field, the same logic applies. What cannot be destroyed must flow. Information, like mass or energy, obeys this principle. It is neither created nor lost, only reshaped by the dynamics of the universe. Even in the most extreme environments, the hearts of black holes, the early moments of the Big Bang, this rule seems to hold. The information contained within a black hole is not annihilated. It becomes encoded in the pattern of its horizon, and as the black hole evaporates through Hawking radiation, that information slowly returns to the universe, diffused like warmth into the cold night of space. What once looked like destruction may instead be the most complex act of redistribution imaginable. If information flows like a fluid, then space-time itself must be part of that fluid. The geometry of the universe would not be a fixed stage, but the shape taken by the current of entanglement. The curvature we call gravity would be the natural response of this current to variations in informational density. Where the flow thickens, space-time curves inward, forming valleys that pull matter toward them. Where it thins, space expands, pushing galaxies apart. The universe breathes through this invisible rhythm. We can even glimpse this relationship through the holographic principle, a discovery that links the physics of gravity with the behavior of quantum fields. According to this idea, everything that happens inside a region of space can be described by information living on its boundary, as if the three-dimensional world were the projection of a two-dimensional surface. When this principle is applied to black holes, the equations describing the horizon turn out to be equations of fluid motion. The black hole's boundary behaves like a viscous fluid, complete with shear, temperature, and diffusion. What we call gravity on the inside behaves like hydrodynamics on the outside. This correspondence is no accident. It is a sign that both phenomena are expressions of a deeper unity. Gravity and quantum mechanics are not rival forces, but reflections of the same underlying current, the hydrodynamics of entanglement. In this view, space-time is not built first, with information flowing inside it. Instead, the flow of information is what builds space-time. The river creates its own banks. When we step back and look at the cosmos through this lens, its structure begins to make new sense. The filaments of galaxies stretching across billions of light years resemble currents in a vast ocean. The clustering of matter, the warping of light, even the acceleration of cosmic expansion may all be manifestations of information seeking balance. The cosmos could be seen as a self-organizing fluid of entanglement, where every local event participates in a global motion toward equilibrium. There is an elegance in this unity. The universe needs no external architect, no fixed framework upon which events unfold. It is self-sustaining motion, the continuous rearrangement of correlations that define what is real. Energy, matter, and geometry are not separate entities, but different ways of describing the same thing. The flow of information through the deep structure of being. And yet, this realization raises a question that sits at the heart of modern physics. If everything flows, if information is conserved but ever-changing, what is the engine that drives the current? Why does information move at all? Why does reality not rest in perfect stillness, its correlations frozen in eternal symmetry? Perhaps the answer lies in instability itself. That perfect stillness is impossible. That fluctuation is fundamental. That the act of existing and the act of flowing are one and the same. If this is true, then the universe is not a creation that happened once and then persisted. It is a creation that is happening continuously, renewed every moment by the motion of entanglement through the fabric of space-time. Every fluctuation, every vibration, every exchange between particles is a tiny act of becoming, a miniature recreation of the cosmos. Reality is not a finished structure, but an ongoing process, a river without a source or a mouth, endlessly moving within itself. If entanglement is the bond that links particles across distance, then its motion is what links moments across time. The universe remembers itself through these flowing connections, like a melody that carries its theme from one note to the next. Each instant is not separate from the one before it. It is entangled with it, shaped by the spread of correlations that reach both forward and backward through time. This is the quiet continuity beneath all change, the current that ensures that the universe does not vanish into randomness with every passing second. When quantum systems evolve, their information does not scatter aimlessly. It spreads in patterns that preserve coherence, echoing the behavior of fluids finding paths of least resistance. The quantum state flows along trajectories determined by symmetry, balance, and conservation, the same guiding principles that shape rivers and winds. In both cases, turbulence arises when too much energy or information accumulates in one place. The system responds by redistributing it, by creating vortices, eddies, and waves. This is how the universe maintains its integrity, through motion that equalizes imbalance. At the heart of this process lies entropy, the measure of uncertainty or information dispersal. In ordinary thermodynamics, entropy tells us how disordered a system has become. But in the realm of entanglement, entropy does not mean chaos, it means connection. As entanglement spreads, the entropy of individual parts increases because each part knows less about itself and more about the whole. This is the paradox of the quantum world, that losing individuality can mean gaining unity. When entanglement entropy reaches equilibrium, the system behaves as though it has thermalized, even if no heat has been exchanged. It becomes a collective whole, each part statistically indistinguishable from the others. This is why physicists describe entanglement as the engine of thermalization, the process by which quantum systems forget their initial conditions and become governed by universal laws. The spreading of entanglement is the flow that drives matter toward balance, much as the flow of heat drives a fluid toward uniform temperature. This principle extends far beyond laboratory systems. In the hearts of stars, in the swirling plasma of galaxies, in the earliest fractions of a second after the Big Bang, the same rules apply. Quantum correlations spread, systems approach equilibrium, and order emerges from motion. Even the cosmic expansion that carries galaxies apart may be an echo of this deep informational balance, the universe stretching to accommodate the continual flow of entanglement within it. In this view, time itself may be nothing more than the unfolding of that flow. Every moment arises from the redistribution of information, from the way entanglement spreads through the fabric of space-time. The arrow of time, the sense that the past is different from the future, may emerge from the direction in which this information disperses. The universe flows not because time pushes it forward, but because flow is what we mean by time. If we could see reality at its most fundamental level, we might not perceive objects or events at all. We might see only patterns of correlation, shimmering and shifting in an endless cascade. Space would appear as the geometry of these patterns, time as their motion, matter as the stable eddies where the flow momentarily lingers. Gravity, energy, and even causality would be secondary effects, the visible ripples left behind by invisible currents of entanglement. The challenge for modern physics is to describe this process precisely, to translate poetry into mathematics without losing its beauty. Researchers build quantum simulators, networks of interacting particles designed to mimic the universe's informational flow. They use tensor networks to map entanglement as a kind of geometry, where the strength of connection between parts defines their spatial relation. In these models, space-time emerges as a web of information, a self-organizing fabric whose shape is determined by how correlations propagate through it. In this geometry, distance is not measured by meters or kilometers, but by entanglement strength. Two regions deeply entangled with each other are close, even if they appear far apart in conventional space. Conversely, regions that share little correlation are distant, no matter how near they seem. The entire concept of location becomes relational, defined not by coordinates, but by connectivity. This way of seeing reality rewrites our understanding of what it means to exist, Objects are not built from matter arranged in space. They are patterns in a flow of entanglement. Their persistence over time is not the endurance of substance, but the stability of correlation. When we touch an object, what we experience is not contact between solid things, but the meeting of flows, the merging of our informational streams with those of the world. Even the act of observation becomes part of the current. When we measure a quantum system, we do not collapse its wave function in the sense of destroying it. We join it. Our measuring devices, our senses, and our minds become entangled with the system, expanding the flow of information to include ourselves. The observer and the observed fuse into a single process, inseparable, continuous. The universe knows itself through the participation of everything within it. If we follow this idea to its end, a new picture of reality emerges. The universe is not a collection of separate things linked by forces. It is a single, evolving organism of information. Space is its body, time is its heartbeat, and entanglement is its circulation, a ceaseless current that nourishes every level of existence. Every star, every cell, every thought is a pattern sustained by that flow. And perhaps, when the last particle fades and the final wave disperses, when the universe cools and the galaxies drift apart, the current will not stop. It will continue to move, subtle and unseen, carrying the memory of everything that ever was. For nothing truly ends in a universe made of flow. The information only changes form, spreading endlessly through the sea of being. The universe does not sit in silence. Beneath every atom, every flicker of light, there is motion, not of matter, but of meaning. When quantum information moves, it does not drift like dust or travel like a signal through air. It expands, weaving new connections, filling the void between possibilities. What we call the evolution of a quantum system is, at its core, the spreading of entanglement, the invisible current that animates reality itself. In the beginning, this motion is subtle. A single particle interacts with another, and the two become linked. Their fates are joined, their probabilities intertwined. But this is only the start of the cascade. As these particles interact with others, the network of entanglement expands, creating a wave of correlation that grows ever wider. Soon the system is no longer describable by the properties of individual parts. It becomes a collective, a sea of relationships in motion. This process is not abstract. It can be seen in experiments with ultra-cold atoms and superconducting qubits, quantum systems chilled to near absolute zero, where noise and thermal chaos fade away, leaving pure informational motion exposed. When physicists disturb these delicate systems, they can watch the spread of entanglement in real time. It does not jump instantly from one place to another. It travels outward like a front, forming a light cone-shaped boundary that marks the limit of how far information has reached. Inside that cone, correlations pulse and swirl, like waves meeting in a pool. Outside it, the universe waits, unentangled for now. This behavior reveals a hidden order. Though quantum mechanics allows for strange and non-local effects, information itself respects a kind of causality. It flows at a finite rate, bounded by the structure of spacetime. This speed is not the same as the speed of light, but it shares a similar role, the ultimate pace at which the universe can share its knowledge of itself. When many particles interact at once, the story grows richer. The flow of entanglement becomes turbulent, like a storm forming in a vast invisible ocean. Regions of the system that were once separate begin to mix, and information from one corner of the quantum world becomes inseparably blended with another. Physicists call this process quantum thermalization, the way isolated systems, even without external influence, evolve towards states of equilibrium simply through the spreading of entanglement. This spreading of quantum information is not just a curiosity, it is what gives rise to the familiar laws of thermodynamics. When entanglement saturates a system, its parts can no longer hold unique information. everything becomes statistically balanced, and temperature, that macroscopic expression of microscopic motion, emerges naturally. Heat, in this sense, is a form of information flow. It is the outward ripple of entanglement made visible to human perception. At first glance, this idea seems almost mystical, that warmth, order, and time themselves might all be shadows cast by the deeper movement of quantum information. But the mathematics supports it. The equations that describe how entanglement entropy changes with time are nearly identical to those governing the diffusion of heat. A sudden disturbance in a quantum system releases a pulse of correlation that spreads just as a drop of dye diffuses through water. Even chaos, that most unpredictable of natural behaviors, is an expression of this same principle. In a chaotic quantum system, small differences in initial conditions grow rapidly, not because particles behave randomly, but because information spreads through entanglement so efficiently that every part of the system becomes aware of every other. The boundaries between cause and effect blur, replaced by an intricate network of correlations. Out of chaos, coherence emerges. This is not mere speculation. In recent years, physicists have learned to measure entanglement directly. They have watched as it spreads across lattices of atoms, forming patterns that echo the laws of hydrodynamics. These experiments reveal something astonishing. Even without particles flowing from one place to another, even without measurable energy transfer, information alone can create currents, pressures, and waves. Entanglement itself behaves like a fluid. Imagine for a moment that the universe is filled with an invisible medium, not the ether of ancient speculation, but a sea of quantum relationships. In this sea, information flows constantly. Every interaction, every observation, every whisper of energy creates ripples that travel through it. These ripples are not disturbances in space-time, they are space-time. The geometry of the cosmos, the curvature we call gravity, the distances that separate stars, all may be patterns in this universal flow. If this is true, then the cosmos is not a collection of objects, but a process, an ongoing evolution of informational currents. Stars, planets, and people are merely stable whirlpools in this great river, maintaining their form as long as the current sustains them. When the current shifts, the whirlpools fade, and their information diffuses back into the whole. Nothing is lost. Everything continues in motion. Quantum chaos, then, is not destruction. It is the natural turbulence of the informational ocean. It ensures that no region remains isolated, that knowledge of every part eventually becomes knowledge of the whole. This universal mixing is what gives rise to the arrow of time, to the steady drift from order to disorder. But even disorder is only an appearance, the visible face of deeper balance. The flow is always conserved. When scientists describe the early universe, they speak of a time when everything was entangled, a primordial state of perfect connectivity. From that unity, expansion began, and the correlations stretched outward, cooling and differentiating into the structures we see. Today, galaxies, stars, and worlds are not remnants of that flow, they are its continuing expression. The cosmos has not stopped unfolding. The river of entanglement still moves, carrying time itself forward. At the smallest scales, quantum information defines the texture of existence. At the largest scales, it defines the shape of the cosmos. Between those extremes lies everything we know: matter, energy, light, and thought, all bound by the same current. To study entanglement is not just to study physics. It is to study the motion of reality's own fabric, the hidden rhythm that turns possibility into form. When physicists first began to explore the spreading of entanglement in quantum systems, they expected something chaotic and unpredictable. But what they found instead was rhythm. Quantum information does not rush randomly through matter. It flows with structure, following laws that mirror the movement of fluids and the spread of heat. Beneath the uncertainty of quantum mechanics lies a quiet regularity. a balance between randomness and order that makes the universe intelligible. Imagine a line of atoms arranged like beads on a string, each one connected to its neighbors through the invisible ties of quantum mechanics. When the first atom is disturbed, its information begins to leak outward. But rather than leaping instantly across the system, it travels with a measurable velocity. Experiments with cold atom traps have captured this phenomenon, a ripple of entanglement moving through the chain like a wave, leaving behind a growing region of shared information. Physicists call this the light cone of entanglement, an invisible frontier that marks how fast the universe can communicate its own changes. The pattern that emerges from these experiments is not random. The correlations follow curves that match the mathematics of diffusion, the same equations that describe how heat spreads through a solid or how perfume disperses through air. Entanglement, though intangible, obeys the logic of flow. Its density can be mapped, its gradients measured, its currents predicted. What we once thought of as a mysterious quantum effect now behaves with the familiarity of a river. But this flow carries something more subtle than energy. It carries meaning, the shared structure of possibility between different parts of a system. When two particles become entangled, their probabilities are no longer independent. Each carries knowledge of the other, even when separated. When that entanglement spreads, this shared knowledge becomes distributed across the whole, like a story retold by countless voices, each adding its own inflection but preserving the essence of the message. The mathematics describing this process has an uncanny beauty. The equations of hydrodynamics, those that govern rivers and oceans, appear again, written in the language of quantum mechanics. There is a continuity equation for information, just as there is for matter. There are currents and viscosities, pressures and flows. In certain strongly interacting quantum systems, these quantities can even be measured as though the system were a liquid, with information diffusing as if it had weight and resistance. This correspondence deepens when we consider black holes. The equations that describe how a black hole returns information through Hawking radiation are strikingly similar to those of a diffusing fluid. A black hole, in this view, is not a static void, but a dynamic process. The fastest mixer of information in the universe. Disturb it in any way, and its surface adjusts almost instantly, spreading the disturbance evenly across its horizon. Physicists call this property the scrambling of information, and black holes are the ultimate scramblers. They mix quantum data so rapidly that no other known system can match them. From this behavior emerges a universal principle. Information, like matter and energy, seeks equilibrium. It flows from regions of high concentration to regions of low concentration, balancing correlations across the system until a steady state is reached. In this way, the universe behaves as though it is constantly seeking informational balance, a kind of thermal calm in which everything knows as much about everything else as possible. At the same time, this flow creates new complexity. Just as turbulence in water gives rise to whirls and eddies, the turbulence of entanglement gives rise to structure. Patterns of stability form within the flow, persistent regions that resist the spread of information for a time. These are the quantum equivalents of whirlpools, particles, atoms, even the larger forms that eventually build galaxies. Every stable object is a temporary pattern in the great current, holding its shape while the river of reality moves through it. The idea that information behaves hydrodynamically bridges two of the greatest pillars of modern science, quantum mechanics and general relativity. On one hand, we have the microscopic laws governing the uncertain world of particles and waves. On the other, the macroscopic laws describing smooth spacetime and the motion of planets and galaxies. For decades, these two realms seemed irreconcilable. Yet when physicists study strongly entangled systems, they find that collective behavior smooths out the quantum chaos, producing equations that look almost identical to those of classical fluids. The quantum becomes continuous, and the continuous begins to behave like the quantum. The boundary between them dissolves. This realization has transformed how we think about emergence. Hydrodynamics is not a separate branch of physics, but a universal language. Any system, no matter how microscopic or complex, will eventually exhibit fluid-like behavior once its internal interactions grow dense enough. The same rules that describe storms and ocean currents apply to the plasma in stars, to the quark soup inside neutron stars, and even to the dance of entanglement itself. The universe, it seems, cannot help but flow. In laboratories around the world, scientists now treat entanglement as something that can be guided and shaped. They speak of entanglement transport, entanglement viscosity, and entanglement temperature, ideas that only a few decades ago would have sounded poetic, not physical. Yet with every experiment, the evidence grows stronger. Quantum information moves like a fluid, obeying laws that are as real as gravity. What makes this even more profound is that such motion may not merely describe how systems behave. It may describe what systems are. If spacetime itself is woven from entanglement, then the hydrodynamics of information is not a metaphor. It is the foundation upon which all other forms of motion depend. The ripples of quantum information are the first waves from which all other waves arise. In this vision, the cosmos becomes a seamless continuum. The flow of galaxies through space, the spread of heat through matter, the movement of thought through the brain, all are variations of a single theme. Information, entanglement, and flow are not separate ideas, but different expressions of one law, that the universe maintains itself through motion. This law has no beginning and no end. It is the pulse of being itself, the ceaseless redistribution of knowledge across the infinite fabric of what exists. And wherever there is flow, there is life. Not necessarily biological life, but the living dynamism of reality, the constant becoming that defines the universe. When information flows, it carries more than numbers and probabilities. It carries the shape of the universe's memory. Every interaction, every entanglement is a trace, a record of how one part of reality has touched another. These traces accumulate and diffuse, creating the continuity that allows the cosmos to evolve coherently. Without this flow, there would be no history, no causality, no sense of before or after. The movement of quantum information is the invisible thread that ties moments together, the deep rhythm beneath time itself. At first, the flow is microscopic, confined to the quantum realm. Two electrons scatter, exchange their spin states, and move on, leaving behind a subtle correlation. But scale this up, trillions upon trillions of interactions per second, and the pattern becomes enormous, stretching across galaxies. Information spreads through the cosmos, not only as light or energy, but as the quiet rearrangement of connections between systems. Every photon that leaves a star carries part of its story, and every atom that absorbs that photon becomes part of that same story. The universe is not just expanding in space, it is expanding in knowledge. In physics, this expansion of knowledge can be described mathematically as the increase of entanglement entropy. Entropy is often misunderstood as disorder, but in the informational sense, it means diversity of connection. As entropy grows, so too does the number of ways the parts of a system can be related to one another. This growth is the essence of time's arrow, not the fading of order, but the widening of possibility. The universe flows from simplicity toward complexity because information seeks to spread. We can see this principle in everything from subatomic reactions to cosmic evolution. When matter collapses into a star, the entanglement among its particles increases, locking their fates together in gravitational unity. When that star burns and releases light, it distributes information back into the cosmos. Even when a star dies and becomes a black hole, its informational balance is not broken. It is hidden, stored in the curvature of spacetime. Every process, no matter how violent, obeys the same rule. Information must flow, but it cannot disappear. This conservation of information is one of the great revelations of modern physics. It tells us that the universe is a perfect ledger, that every event, every interaction, every whisper of energy is written into the fabric of reality and remains there forever. The apparent loss of information, such as what seems to happen when something falls into a black hole, is only a misunderstanding of how that information is encoded. It is not gone. It has simply changed its form, redistributed across the vast fluid of space-time. Such a view changes the meaning of emptiness. What appears as void is not absence, but potential, a medium filled with the constant exchange of quantum information. Even the vacuum hums with virtual particles appearing and vanishing, their fleeting existence maintaining the balance of the whole. Space itself behaves like an ocean, whose surface we can never fully still. The ripples of entanglement move through it ceaselessly, shaping geometry, mass, and energy. To describe this mathematically, physicists turn to models that merge quantum theory with thermodynamics. They use tools from fluid dynamics to understand how entanglement spreads, dissipates, and stabilizes. The result is a strange new form of hydrodynamics, one that governs not water or air, but the invisible substance of reality's correlations. In these equations, space-time is not a backdrop, but a participant. It bends and twists in response to the currents flowing through it. In laboratories, these ideas find support in systems that behave like miniature universes. When physicists trap ultra-cold atoms in optical lattices and disturb them, the resulting patterns of entanglement mimic the expansion of the cosmos itself. The correlations spread outward, forming structures that resemble shock waves or vortices in a fluid. The language of hydrodynamics, pressure, flow, viscosity, applies perfectly, even though nothing material is moving. The only thing in motion is information. The key insight from these experiments is that entanglement behaves universally. No matter the system, no matter the scale, its flow follows the same patterns. In the simplest chains of qubits and in the hearts of the most massive stars, information spreads according to laws that look remarkably alike. The micro and the macro are reflections of each other, connected by the same underlying mathematics. This unity suggests that the universe is not divided into separate regimes of behavior. It is one continuous process viewed at different magnifications. If space-time and matter both arise from the movement of entanglement, then the equations of general relativity, those that describe the curvature of space and the pull of gravity, may themselves be the large-scale expression of an informational flow. Gravity could be the hydrodynamic limit of quantum information dynamics. The way a river seen from a distance looks smooth, even though it is composed of countless swirling currents. This idea gives new meaning to the phrase, the fabric of space-time. It is not a fixed cloth, but a living current, a tapestry being woven and rewoven at every moment by the motion of information. Every gravitational wave, every burst of light, every flicker of heat is a sign of that ongoing rearrangement. When a massive star collapses and sends ripples through space, what we are seeing is not matter alone, but the deep current of entanglement reshaping geometry. And if gravity itself is born from this flow, then perhaps the other forces of nature are too. The electromagnetic, strong and weak interactions may all be different modes of the same underlying movement. Patterns of information flow stabilized at different scales and symmetries. The unity that physicists have long sought, the dream of a single theory describing all forces, may already exist in the simple principle that everything flows. In this vision, the cosmos is not a hierarchy of parts, but a hierarchy of motion. What we call particles are stable eddies in the current. What we call forces are the gradients that move it. The equations of physics are not laws imposed from outside, but descriptions of balance within the flow. The universe is self-regulating, self-organizing, and self-renewing, an eternal circulation of information. Perhaps this is what ancient thinkers intuited when they spoke of the world as a living whole. They could not know the mathematics of quantum mechanics or relativity, but they sense the same truth, that life, matter, and consciousness are waves in one boundless sea. Modern science, after centuries of separating and categorizing, is now rediscovering that unity in the most precise way possible. If all of this is correct, then every movement we witness, from the drifting of galaxies to the flicker of neurons, is a reflection of the same hidden current. Every act of creation, every moment of thought, every breath of existence participates in the hydrodynamics of entanglement. The universe is not a static structure that happens to contain motion. It is motion, unfolding into form again and again. And as we follow this flow, deeper, the distinction between the quantum and the cosmic begins to fade. The smallest ripples of entanglement may be the seeds of the largest patterns of space-time. The river of information that begins in the subatomic world may swell to become the cosmic tide that carries galaxies. The same mathematics that governs the spreading of entanglement in a handful of atoms may one day explain the shape and fate of the entire universe. When we first learn about the universe, we are told that it is made of particles, tiny, indivisible points dancing through empty space. They collide, scatter, and form the atoms that build the world. But this picture, though elegant in its simplicity, hides a deeper truth. Beneath the precision of particle physics lies another language, one that speaks not of points, but of patterns, not of impacts, but of flow. This is the language of hydrodynamics, the universal grammar of motion. Everywhere we look, from clouds in the sky to the molten hearts of planets, we find that nature prefers continuity. When countless particles move together, their individuality dissolves, and the collective begins to speak a simpler dialect. Pressure, density, velocity. These are the words of that dialect. They emerge when chaos becomes cooperation, when countless microscopic motions blend into smooth, visible order. Hydrodynamics was first born from water. Early scientists studied rivers, tides, and storms, searching for rules in their turbulence. They discovered that fluids, though chaotic in detail, obeyed laws that were exact in form. Whether the fluid was water, air, or molten rock, its motion could be described by the same equations. Those equations, the continuity equation and the Navier-Stokes equation, became some of the most powerful in physics. They said, in essence, that what flows into one region must flow out of another, and that the change of momentum in any small volume depends on pressure and friction. But as our understanding deepened, the reach of these equations grew. They were found to govern not only water and air, but plasma, crowds, galaxies, and even the collective behavior of particles at the quantum scale. The universe, in its restless motion, seems to obey the same rules everywhere. Hydrodynamics, it turns out, is not the science of water, it is the science of motion itself. The beauty of this realization is that hydrodynamics does not care what the fluid is made of. Whether it is hydrogen gas in a nebula or electrons in a superconductor, the same principles apply. As long as the system can carry momentum, as long as there is something that can move and interact, the language of hydrodynamics speaks clearly. It is the universal dialect of motion. Now imagine applying this language not to matter, but to information. If entanglement behaves like a fluid, spreading, diffusing, and balancing itself, then the universe's deepest behavior can be described by the same equations that describe rivers and winds. Where water flows through space, information flows through reality. Both are governed by conservation laws. Both are shaped by gradients and pressures. Both give rise to turbulence and structure. Physicists have discovered that even in the quantum realm, where particles behave like waves and probability replaces certainty, hydrodynamics emerges naturally. When a system becomes strongly interacting, when countless quanta entangle and share information, their collective motion smooths into flow. The mathematics simplifies, and what once seemed random becomes predictable. The whole behaves as one. This emergence of hydrodynamics from chaos is one of the universe's great harmonies. It shows that complexity, when deep enough, produces simplicity. The same principle that governs storms on Earth may govern the behavior of black holes and the expansion of galaxies. Every form of motion, from the smallest to the largest, is a variation on the same theme, the balancing of flow. In the dense plasma that fills the hearts of stars, particles move with such intensity that no single trajectory can be followed. Yet, when taken together, their motion behaves like that of a perfect fluid. Their collisions smooth into continuity. Their heat becomes a wave that ripples through the star. The equations that describe this are identical in form to those that describe a river's current. The same patterns repeat at every scale. Hydrodynamics also reveals a deep truth about the universe's efficiency. When systems evolve, they tend toward configurations that dissipate energy and information as smoothly as possible. Turbulence, though chaotic to the eye, is often the most efficient way for a system to distribute motion and maintain balance. The swirling of water behind a rock, the eddies in a storm, the filaments of galaxies, all are nature's way of reconciling forces, of finding equilibrium through flow. If the motion of information follows similar rules, then the universe's structure, from the distribution of matter to the geometry of space-time, may be a direct consequence of this hydrodynamic efficiency. Space itself could be the smoothest possible way for quantum information to arrange and balance its connections. Gravity, light, and time would then be the visible expressions of that balance. This brings us to one of the most remarkable unifications in modern science: the realization that gravity and fluid motion are not opposites, but reflections. The equations that describe how space-time curves under the influence of mass can be rewritten in a form nearly identical to those that describe a moving fluid. In certain conditions, a patch of space-time behaves like a viscous medium, its curvature responding to stress and flow just as water responds to wind and pressure. This connection is not theoretical speculation. It arises naturally from the holographic principle, the idea that all the information contained within a region of space can be represented on its boundary. In this framework, gravity in higher dimensions corresponds to fluid dynamics in lower ones. The surface of a black hole, for instance, behaves exactly like a fluid membrane. It has temperature, entropy, and viscosity. It can flow, vibrate, and even produce waves. The hydrodynamics of space-time is therefore not a metaphor, but a literal truth. The universe, at its most fundamental level, behaves as though it were a fluid of information, flowing and reshaping itself according to the same equations that govern the motion of air and water. When we study the patterns of the cosmos, we are studying the same mathematics that describes a river's surface, only written in the language of stars and time. To see the cosmos this way is to realize that physics is not a collection of separate laws, but a single idea expressed through countless forms. Motion and information, energy and geometry, all are facets of the same continuity. The universe does not contain flow, it is flow. And the language that best describes that flow, from quarks to quasars, is hydrodynamics. When quantum systems grow large, when their parts entangle beyond count, the individual becomes irrelevant and the collective takes command. It is here, at the threshold between chaos and coherence, that hydrodynamics reveals its universal power. The same laws that govern storms in the atmosphere begin to govern the flow of information and energy through the quantum realm. The microscopic and the cosmic merge in one continuous description, the mathematics of motion made manifest. To understand this unity, imagine the plasma that fills the first moments of the universe. It was a state so dense and hot that no atoms could form, only a fluid of free quarks and gluons swirling in all directions. Every particle collided with every other almost instantly, so often that no single path could be traced. And yet, when physicists recreate this primordial plasma in particle accelerators, they find that it behaves not chaotically, but with astonishing smoothness. It flows like a perfect liquid, nearly without viscosity. The quark-gluon plasma, born from the most violent conditions imaginable, turns out to be one of the most fluid substances in existence. This discovery revealed something profound. When matter reaches its most extreme state, its behavior is best described not by particle mechanics, but by fluid dynamics. The individual disappears into the collective, and the collective becomes simple again. The same pattern repeats everywhere, in the atmosphere of Jupiter, in the accretion disks around black holes, in the streaming of interstellar gas. When complexity reaches its peak, hydrodynamics emerges as nature's most stable language. Physicists realized that this universality could not be coincidence. It suggested that hydrodynamics is not just a convenient approximation, but a fundamental consequence of how the universe organizes motion. Whether the medium is air, plasma, or spacetime itself, the equations of flow describe the limit toward which all systems evolve when left to interact. When quantum information spreads through an entangled system, it behaves in precisely the same way. Initially, discrete interactions give rise to continuous currents. Regions of high informational density push outward, diffusing into regions of low density until balance is restored. Therefore, correspondence between this process and the equations of fluid motion is exact. The same conservation principles, the same gradient-driven flows. What moves is not matter, but meaning, not energy, but relationship. This deep symmetry between quantum dynamics and hydrodynamics forms a bridge between the smallest and largest scales of reality. On one side stand the quantum fields that define particles. On the other, the smooth curvature of spacetime described by general relativity. Between them flows the mathematics of continuity, the recognition that what connects all scales is the tendency of systems to move information as efficiently as possible. The holographic principle strengthens this bridge. It proposes that everything within a region of space can be represented by information living on its boundary. In this framework, the gravitational dynamics of a higher dimensional space are mathematically equivalent to the fluid dynamics of its lower dimensional edge. Gravity and flow, geometry and thermodynamics turn out to be two descriptions of the same underlying process. When applied to black holes, this duality becomes explicit. The event horizon behaves like a viscous membrane, capable of vibrations, waves, and flows. Its entropy measures the total information contained within, while its temperature defines how that information moves. When disturbances ripple across its surface, they follow equations identical to those that describe sound waves in air or ripples in water. Gravity, it seems, is the hydrodynamics of entanglement, the flow of information made geometric. This realization transforms the way we think about spacetime. It suggests that geometry itself is not fundamental, but emergent. The smooth curvature we perceive is the large-scale result of countless microscopic flows of entanglement. Where information is dense, spacetime bends inward. Where it thins, spacetime expands. The fabric of the universe is thus a record of informational pressure, the hydrodynamic texture of correlation itself. Even the ripples we detect as gravitational waves, those faint undulations in the structure of space caused by merging black holes, can be viewed as sound waves in this fluid of geometry. They carry information through spacetime, just as waves carry energy through water. Their passage reminds us that the universe is not solid, but alive with motion, a sea of meaning forever in flux. If we accept this, then the distinction between the quantum and the cosmic begins to dissolve. There is no true divide between particle physics and astrophysics, between micro and macro, between information and energy. They are the same current viewed through different lenses. Hydrodynamics is the universal translation between them, the grammar through which the cosmos speaks its own structure. In this light, the great unification that physicists have sought for generations may not come from inventing new particles or forces, but from recognizing that all of nature's behavior is a form of flow. The equations of quantum fields, the equations of general relativity, and the equations of fluids may all be expressions of one deeper law, that the universe is self-balancing, self-communicating, and self-sustaining through the perpetual motion of information. The challenge that remains is to write this law precisely, to capture in mathematics the full elegance of what hydrodynamics hints at. But even before that is done, the vision it offers is irresistible. A universe that is not built from static components, but from currents, not made of matter, but made of motion, not constructed once, but continuously created through the ceaseless flow of entanglement. The universe is a story told twice, once in the language of matter and once in the language of information. On one side, we see stars, galaxies, and gravity sculpting the great architecture of the cosmos. On the other, we find quanta, probabilities, and entanglement weaving the invisible fabric beneath. For centuries, these two narratives have seemed irreconcilable. One describes the smooth flow of space-time, the other, the jittering dance of uncertainty. Yet the closer we look, the more clearly we find that they are not separate stories at all, but mirrored reflections of one truth. The bridge between them is holography, the profound realization that gravity and quantum information are two faces of the same current. The seed of this idea was planted in the late 20th century when physicists studying black holes uncovered a paradox. According to the principles of quantum mechanics, information can never be destroyed. Every interaction, every quantum event, must preserve the total information of the universe. Yet when matter falls into a black hole, it appears to vanish beyond the event horizon, lost to the cosmos forever. Stephen Hawking's discovery that black holes radiate and evaporate over time only deepened the mystery. If a black hole disappears completely, where does its information go? The solution, strange and elegant, was the holographic principle. It proposed that the information swallowed by a black hole is not lost, but encoded on its surface, the event horizon itself. The three-dimensional interior of the black hole, with all its mass and volume, is represented entirely by a two-dimensional layer of information on its boundary. The black hole, in essence, behaves like a hologram, a three-dimensional image projected from a two-dimensional surface. This revelation shattered the old distinction between inside and outside, between volume and surface, between reality and its description. It implied that the universe itself might be holographic, that everything within a region of space could be described by information living on its boundary. The three-dimensional world we perceive may be an emergent projection of a deeper informational flow existing in lower dimensions. Juan Maldacena transformed this intuition into mathematics through what is now called the ADS-CFT correspondence. In this framework, a gravitational universe living in a higher dimensional space, the bulk, is equivalent to a quantum field theory without gravity living on its boundary. The two descriptions are perfectly correlated. Every vibration of space-time curvature inside the bulk has a counterpart in the flow of quantum information along the boundary. Gravity and quantum entanglement are not separate forces, but reflections of one another. What makes this correspondence astonishing is that it unites the smoothness of general relativity with the discreteness of quantum mechanics. The chaotic dynamics of countless entangled particles can, when viewed through this holographic lens, reproduce the graceful curvature of space-time. The geometry of the universe is not a fixed arena for events, but the collective shape taken by information as it flows and equilibrates. When physicists examined the mathematics more closely, they discovered that the equations governing gravity in the bulk, Einstein's equations, could be derived directly from the behavior of entanglement entropy on the boundary. In other words, the bending of spacetime corresponds to the flow of quantum information. Where information is dense, spacetime curves inward. Where it thins, spacetime stretches outward. Gravity itself is the hydrodynamics of entanglement. This view transforms what we mean by geometry. The smooth curvature that guides planets and bends light is not an inherent property of space, but but a macroscopic expression of microscopic connections. It is the averaged behavior of countless quantum correlations, flowing and balancing to maintain equilibrium. Space is the map of entanglement, and time is the rhythm of its rearrangement. In this holographic universe, even the black hole paradox finds peace. The information that falls inward becomes encoded on the horizon, where it diffuses like heat through a fluid surface. As the black hole radiates, this information slowly leaks back into the cosmos, not as destroyed data, but as redistributed correlations. The horizon behaves like a viscous membrane, its motion governed by equations identical to those of fluid dynamics. It has a temperature, a pressure, and a viscosity, and the ratio of that viscosity to its entropy density turns out to be almost universal, the same in black holes as in the quark-gluon plasma created in laboratories. The unity of these phenomena is breathtaking. The most extreme gravitational object in the cosmos behaves like a drop of quantum fluid, while the tiniest droplets of matter in particle accelerators behave like miniature black holes. The boundary between gravity and quantum mechanics dissolves entirely. Both are expressions of the same underlying law, that information flows according to principles of balance, conservation, and diffusion. Through holography, the cosmos becomes self-reflective. The surface encodes the volume, the part contains the whole. The distinction between observer and observed fades because each is mirrored in the other. The holographic principle thus restores symmetry to reality, a symmetry not of position or energy, but of knowledge. Even the fabric of space-time itself may be nothing more than the record of how information is shared. If the connections between quantum systems define geometry, then the shape of the universe is the shape of entanglement. To change curvature is to rearrange correlations. Gravity, seen this way, is not a force pulling masses together, but the result of information seeking balance across the cosmic network. This insight gives new meaning to Einstein's statement that space tells matter how to move, and matter tells space how to curve. Both motions are the same motion, the flow of information. The curvature of spacetime is the geometry of entanglement, and the movement of matter is the evolution of that geometry through time. The universe is a single conversation between its parts, spoken through the grammar of holographic flow. In laboratories and simulations, physicists are now building artificial holographic systems to explore this bridge. Using networks of qubits, they create simplified universes where the equations of quantum mechanics on a lower dimensional boundary generate an emergent geometry in higher dimensions. These experiments show, in miniature, how space and gravity might arise from entanglement alone. They reveal that the universe is not a thing, but a process, the continual weaving of connectivity into form. The implications stretch beyond physics. If space and time are emergent, then so too are the boundaries that separate objects, events, and even selves. Reality is not composed of isolated entities, but of relationships, each one defined by its connections to the rest. Existence itself is holographic, every part containing echoes of the whole. As we stand on this holographic bridge between gravity and quantum flow, the cosmos begins to look less like a machine and more like a living system, a self-sustaining network of information currents that gives rise to everything we see. And just as a river carves its own path while being shaped by the land it moves through, so too does the flow of entanglement sculpt the geometry that guides it. The universe is both the current and the channel, the message and the medium, forever intertwined. In the holographic universe, every surface becomes a storyteller. What lies within a volume is not lost to the depths of space, but inscribed delicately upon its boundary. Every particle, every quantum fluctuation, every ripple in space-time is mirrored on an outer skin, an informational horizon that holds the memory of everything it encloses. The cosmos, seen through this lens, is not infinite in dimension, but infinite in detail. Reality, it seems, prefers compression, a perfect efficiency of description where less space holds more truth. To understand how gravity arises from this principle, imagine the surface of a black hole not as an edge, but as a living field. It vibrates, it ripples, it breathes with the fluctuations of the quantum world. Each vibration encodes the history of what has fallen in and what the universe has lost to its shadow. The equations describing these vibrations are indistinguishable from those describing waves in a fluid. The black hole's horizon has a temperature, a viscosity, and even a speed of sound. The curvature of spacetime becomes a thermodynamic surface, and the flow of gravity becomes indistinguishable from the flow of heat. This is more than an analogy. When physicists translate the mathematics of Einstein's general relativity into the language of thermodynamics, the two become nearly identical. Pressure corresponds to curvature, entropy corresponds to area, and the flow of energy corresponds to the flow of spacetime itself. In this way, gravity behaves as a hydrodynamic limit, the large-scale, smoothed-out behavior of the microscopic flow of quantum information. When we see a planet orbit a star, what we are really watching is the equilibrium between two information currents, each one shaping the other's path through the fluid of spacetime. The holographic principle gives this unity a clear architecture. In the ADS-CFT framework, a gravitational universe in a higher dimensional bulk corresponds precisely to a lower dimensional quantum field theory on its boundary. Every dynamic inside, every motion of matter, every curve of geometry has a matching pattern of information flow on the outside. The universe, therefore, is a perfect dialogue between surface and depth, between energy and information, between what bends and what flows. Even more striking is what this reveals about the laws of thermodynamics themselves. The entropy of a black hole, proportional to the area of its event horizon, is the key to understanding the deep structure of spacetime. It tells us that the amount of information required to describe a region of space depends not on its volume, but on its surface. This is profoundly counterintuitive, yet it explains why the universe can remain finite in information content even while appearing infinite in extent. Reality is not stored in the bulk, it is etched on the edges. The holographic view also clarifies why space-time behaves so smoothly. If the geometry of the cosmos arises from the collective flow of information, then small fluctuations average out just as turbulence smooths into laminar flow in a river. The apparent stability of space-time, its ability to sustain stars, planets, and the passing of time, is the hydrodynamic calm that emerges from a sea of underlying quantum fluctuations. In this sea, entanglement is the current. When information becomes dense, curvature increases. When it thins, space expands. Gravity is not a fundamental force, but the natural response of the information flow to imbalance. A massive object, rich in information density, draws in its surroundings not through invisible attraction, but through the pressure of entanglement equalizing itself across space-time. The universe curves to maintain informational harmony. The mathematics of holography has revealed patterns that mirror those of fluid motion with uncanny precision. Black hole horizons obey equations that look exactly like the Navier-Stokes equations for a viscous fluid. Gravitational perturbations propagate as sound waves in that fluid, while temperature gradients across the horizon generate flows of entropy analogous to heat currents. The deeper physicists probe, the more fluid-like spacetime becomes. The vacuum, far from being empty, behaves like a medium with measurable viscosity, conductivity, and compressibility. A cosmic fluid whose motion defines reality. And yet, this cosmic fluid does not exist in ordinary space. It is space. The geometry of the universe is its shape, the passage of time, its evolution. What we experience as gravity, as expansion, as the curvature of space-time, are all manifestations of how this informational fluid moves. The cosmos, then, is not a stage for events, but the event itself, a flow that generates its own container, a current that creates the channel through which it moves. This self-referential nature of the universe, this endless recursion of information describing information, is what gives holography its profound beauty. The surface reflects the volume defines the surface, and each contains the complete image of the other. It is a cosmic feedback loop, an equilibrium between knowing and being, between form and flow. When we observe the cosmos through a telescope, we are not merely seeing light that has traveled across space. We are witnessing the echoes of informational currents imprinted upon the boundaries of space-time itself. Every photon carries a holographic trace of its origin, a whisper of the deeper structure that sustains it. The light we see is not separate from the geometry it travels through. It is part of the same dance of flow and curvature. In this view, the universe is not a vast emptiness sprinkled with stars, but a continuous, self-writing hologram, a fluid of entanglement generating its own geometry through motion. Gravity, once thought to be the weakest of the fundamental forces, becomes instead the most eloquent expression of information's desire to flow smoothly. Where the current meets resistance, space-time bends. Where it flows freely, space-time stretches wide. This realization dissolves one of the oldest divides in human thought, the divide between matter and meaning. What we call matter is not a substance. It is information moving through the geometry it helps create. What we call space is not void. It is the structure that information carves as it moves. Reality is thus neither particle nor wave, neither substance nor shadow, but a holographic symphony of motion, an orchestra of currents where gravity plays the rhythm of balance. In the holographic universe, geometry is no longer a passive background. It is a living participant in the great current of entanglement. Every fold of space-time, every ripple of gravity, every stretch of cosmic expansion arises from the same underlying motion. This is not an abstract metaphor. It is the literal hydrodynamics of information, the flowing, diffusing, balancing of quantum correlations that generate the geometry we call reality. Physicists describe this emergence with a simple yet astonishing idea, that the shape of space-time follows the gradients of entanglement entropy. When two regions of the universe are deeply entangled, the distance between them effectively shortens. When their entanglement weakens, the distance grows. Geometry, then, is nothing more than the map of how information is shared. Space is not a container, it is a relationship. At small scales, this geometry is woven from countless threads of quantum connection, each one linking microstates into a coherent structure. As we move to larger scales, those threads merge into smooth surfaces, the continuous curvature of general relativity. The Einstein field equations, long thought to describe the behavior of gravity, turn out to be the macroscopic expression of information trying to reach equilibrium. Gravity is not a fundamental force acting within spacetime. It is spacetime's response to the movement of entanglement across its surface. Consider the simplest form of this principle, the entanglement first law. It states that a small change in the geometry of space corresponds exactly to a small change in entanglement entropy. When information flows from one region to another, space-time bends to compensate, preserving the overall balance. The same mathematics that governs thermodynamic equilibrium governs gravitational equilibrium. The same laws that describe the diffusion of heat describe the curvature of space. In this way, space-time behaves like a fluid. Its geometry can flow, stretch, and oscillate. Gravitational waves, which ripple through the universe when massive objects collide, are not distortions traveling through a rigid structure. They are sound waves in the fluid of reality itself. The energy they carry is not something that moves through space. It is the reshaping of space as information flows from one configuration to another. This vision of space-time as an entanglement fluid is not just poetic. It is supported by the mathematics of holography and the thermodynamics of black holes. When physicists calculate the temperature, entropy, and viscosity of a black hole horizon, they find universal ratios that match those of the most perfect fluids known. The viscosity to entropy ratio of a black hole horizon is the same as that of the quark-gluon plasma created in laboratories, suggesting that both are expressions of the same principle at different scales, information flowing toward balance with the highest possible efficiency. Even the expansion of the universe can be seen through this lens. As space-time stretches, entanglement spreads. The cosmic horizon, the boundary beyond which we cannot see, behaves like the surface of a black hole, encoding the information of everything within. As galaxies drift apart, they do not move through pre-existing space. They are carried by the expanding flow of entanglement itself. The universe is not moving in space, it is the motion of space. This redefinition of geometry transforms the way we understand existence. The universe is not built from matter occupying space, it is built from information shaping itself into form. Every atom, every star, every thought is a knot in the current of entanglement, a local configuration of correlations that temporarily resists diffusion. What we perceive as solid, enduring matter is simply a stable whirlpool in the endless fluid of information. If this view is correct, then the boundary between physics and philosophy vanishes. To exist is to participate in the flow. To move is to exchange information. To think is to generate new currents in the ocean of correlation. Even consciousness, that most mysterious of phenomena, may arise from patterns of entanglement within the brain's quantum and classical networks, mirroring the structure of the cosmos itself. Thus, the holographic bridge does more than connect gravity and quantum theory. It unites the human and the cosmic, the material and the abstract. It shows that everything from the smallest vibration to the largest galaxy is part of a single, continuous fluid of information, a living geometry that writes and rewrites itself endlessly. The journey of science, then, is not to escape this flow, but to listen to it, to learn its rhythms and recognize that we, too, are part of the current. Our thoughts, our discoveries, our acts of observation are all ripples in the same sea, reflections of the same motion that bends light and carries time forward. In the end, the holographic bridge teaches us that reality is not built from things, but from connections. It is not a machine, but a conversation, not a static cosmos, but a continuous unfolding. The equations of gravity, the logic of thermodynamics, the dance of entanglement, all are verses in the same poem. And that poem is written in the language of flow, the hydrodynamics of information that underlies all creation. Space has always seemed like emptiness, a quiet background against which the universe performs its grand motions. But the closer we look, the less empty it becomes. What we once called vacuum is now understood as a sea of fluctuations, a restless medium in which virtual particles appear and vanish, where fields intertwine and exchange information even in silence. It is not a void, but a current, and that current is made of entanglement. Spacetime, it seems, is not a stage for events, but the very flow of information that makes events possible. The idea that entanglement could be the substance of space itself began as a whisper in the mathematics of quantum gravity. Physicists noticed that the equations describing spacetime curvature could be rewritten as statements about how entanglement entropy changes. This strange correspondence, first glimpsed in holographic theories, grew into something profound. Small variations in geometry correspond exactly to small variations in quantum correlations. In other words, the shape of the universe is the shape of information. Imagine two regions of space, A and B. If the quantum states within them are strongly entangled, then the distance between them shrinks. They behave as though connected by a bridge, invisible yet real. If their entanglement weakens, the bridge stretches and space between them expands. This dynamic interplay defines geometry. The universe bends and stretches not because of invisible forces, but because information flows unevenly through its structure. In this way, gravity emerges naturally. Where information is dense, space-time curves inward. forming valleys in which matter gathers. Where information thins, space-time expands, creating the voids between galaxies. Gravity is not a fundamental force acting across distance. It is the pressure of entanglement seeking equilibrium. The cosmos, from this perspective, is an ocean of information balancing itself at every scale. The mathematics describing this process mirrors that of fluids. There are informational currents, pressures, and viscosities. When information moves freely, space-time flows smoothly. When it meets resistance, curvature forms. The same equations that describe the flow of water in a river describe, in another language, the flow of entanglement through the fabric of reality. To see this in action, physicists turn to the holographic universe, where gravity in higher dimensions maps to quantum behavior in lower ones. The boundary of this universe behaves like a fluid membrane, its patterns of entanglement determining the shape of the higher dimensional bulk. When information moves along the boundary, geometry shifts within the bulk, as though space-time itself were a reflection of that informational flow. The entire cosmos becomes a self-regulating network of relationships, where the motion of entanglement writes the contours of existence. This vision turns traditional cosmology inside out. Instead of matter shaping space, it is information that sculpts both matter and space together. The galaxies, stars, and planets we see are not embedded in space-time. They are space-time, condensed into form by the flow of entanglement. Every structure in the universe, from the smallest particle to the largest cluster of galaxies, is a vortex in this vast informational fluid. Even the speed of light, that cosmic constant, may be a reflection of how quickly information can propagate through the fabric of entanglement. Just as sound waves have a maximum speed in a given medium, the light speed limit may be the characteristic velocity of the universe's informational flow. Beyond that rate, the fluid cannot transmit correlation, and causality itself breaks down. The laws of physics, then, are not imposed from outside, but arise from the properties of this quantum fluid. In this picture, time also takes on new meaning. It is not a line, but a current, the continuous redistribution of information through the universe. The arrow of time points in the direction of increasing entanglement as correlations spread and complexity grows. The future is simply the region toward which information has not yet flowed. The past is the wake left behind in that current. This understanding reshapes even the notion of energy. What we call energy may be nothing more than the measure of informational tension, the imbalance that drives the flow. When a particle moves or a star burns, information shifts, correlations rearrange, and the geometry of space-time adjusts accordingly. Conservation of energy is thus conservation of information, written in another dialect. The universe does not consume or lose energy, it reconfigures its entanglement endlessly. When physicists calculate the thermodynamics of space-time, they find the same patterns again and again. The temperature of a black hole, the entropy of the cosmic horizon, the expansion rate of the universe, all follow laws identical to those of fluids and heat. Even Hawking radiation, the gentle glow from a black hole's edge, can be seen as the slow leakage of information from one region of space-time to another, maintaining balance in the cosmic flow. In this sense, space-time itself behaves like a perfect conductor of information. It transmits correlations without loss, ensuring that every interaction, every fluctuation, is accounted for in the great conservation of meaning. This perfection, however, is not static. It is dynamic, self-correcting, and creative. Where turbulence arises, new structures form: stars, galaxies, and perhaps even consciousness. The universe does not merely allow complexity, it produces it naturally, as vortices form in the ever-flowing sea of entanglement. The boundaries of this fluid are subtle. There is no wall separating inside from outside, no edge where the universe ends. The only boundaries that exist are informational, horizons where the flow becomes inaccessible to an observer. The event horizon of a black hole is one such boundary. The cosmic horizon, beyond which we cannot see, is another. Each horizon encodes the information hidden beyond it, maintaining the continuity of the whole. Thus, what we perceive as the fabric of reality is not a silent void, but a living ocean of entanglement, shimmering, self-aware, and ceaselessly in motion. Every quantum fluctuation, every gravitational wave, every burst of light is a ripple in that ocean, a sign of its unending flow. To study the universe is to study the movement of information, the hydrodynamics of the infinite. In the universe's deepest layer, the separation between space, time, and information disappears. What we call geometry is not an independent structure, but a consequence of how entanglement organizes itself. The entanglement first law reveals this connection with astonishing clarity. It states that for small variations around equilibrium, the change in entanglement entropy of a region is directly proportional to the change in the energy contained within that region. When translated into geometric language, this becomes the very equation that Einstein discovered, the relation between energy and curvature. The flow of information and the bending of space-time are the same event described in two dialects of one truth. This realization reframes everything. Gravity is no longer a fundamental interaction, but an emergent phenomenon, a statistical behavior of countless quantum correlations seeking balance. Just as temperature emerges from the collective motion of molecules, gravity emerges from the collective motion of entanglement. It is not a force pulling objects together, but the natural curvature that forms when information strives for equilibrium. To visualize this, imagine a region of space as a patch of fabric woven from invisible threads of correlation. Each thread represents entanglement between quantum states. When information flows, when one part of the system becomes more entangled with another, the fabric stretches or bends to accommodate that change. The denser the connections, the deeper the curvature. A massive object is simply a knot in this web, a concentration of informational pressure that warps the surrounding geometry. This model explains why spacetime behaves so fluidly. When matter moves, the surrounding geometry shifts instantly to preserve informational continuity. The curvature responds to maintain balance, just as a liquid surface adjusts to a disturbance. The equations of general relativity, which describe how mass and energy curve space, are thus the macroscopic manifestation of this microscopic fluid behavior. The holographic correspondence strengthens this view. It tells us that the information describing the entire bulk of space-time is encoded on its boundary, like ripples on the surface of a pond describing the currents below. The energy and momentum in the bulk correspond to flows of entanglement entropy on the boundary. In this sense, gravity is, literally, the hydrodynamics of information. When physicists simulate entanglement patterns in quantum systems, they find structures that resemble the geometry of curved space. Tensor networks, which map how quantum states entangle, form shapes that mimic the geometry of anti-de Sitter space, the same geometry used in holographic theories. The deeper one moves into the network, the more layers of entanglement one crosses, just as moving inward in the holographic bulk corresponds to moving deeper into space-time. Geometry, it seems, is nothing but the large-scale image of informational connectivity. Even time behaves according to this logic. The progression of moments is the evolution of entanglement, the continual reweaving of connections between quantum states. The arrow of time points toward greater entanglement, toward the diffusion of information into broader patterns. In this sense, the expansion of the universe, the aging of stars, and the flow of consciousness are all aspects of the same current. Time is not an external clock, it is the rhythm of entanglement spreading through reality. At every scale, from atomic to cosmic, this hydrodynamic motion leaves its mark. The heat of a black hole, the cooling of the early universe, the distribution of galaxies, all follow from the same thermodynamic balance of information. When energy moves, so does entanglement. When entropy increases, geometry shifts to accommodate it. The second law of thermodynamics, which governs the growth of disorder, becomes the law of cosmic evolution, the universe's inexorable tendency toward more complex entanglement. Yet within this growth, order emerges. The same flow that increases entropy also creates structure, just as turbulence in a fluid generates patterns of astonishing beauty. Stars, planets, and living systems are all temporary islands of order, formed by the currents of entanglement, eddies, in the greater sea of diffusion. They are not exceptions to the second law, but expressions of it, ways in which the universe explores new configurations of information while maintaining overall balance. Even consciousness, in this view, might be understood as a localized awareness within this flow, a recursive pattern of entanglement complex enough to reflect on itself. Just as space-time curves in response to information gradients, the mind may arise in response to informational complexity within the brain's networks. Awareness could be the fluid dynamics of entanglement occurring at biological scales, the cosmos thinking through one of its own vortices. The hydrodynamic picture of space-time offers something rare in physics, a sense of unity between the laws of nature and the experience of existence. It shows that the same principles guiding the motion of galaxies also guide the formation of thoughts. It reminds us that we are not observers standing outside the flow, but participants within it. Every perception, every idea, every breath is a small rearrangement of information within the universal current. In this endless circulation, nothing is truly lost. Information may diffuse, spread, and transform, but it never vanishes. Even the death of stars and the evaporation of black holes are not acts of destruction, but of translation, the conversion of one form of entanglement into another. The universe is an eternal recycler of correlation, a self-sustaining river that never ceases to flow. To grasp this is to see the cosmos not as a mechanism, but as a living system. A self-organizing, self-reflective entity that generates its own structure through motion. The geometry of space-time is its body. The flow of entanglement is its pulse. The stars are its flickering neurons, the galaxies its great circuits of thought. And we, for an instant, are conscious ripples within its boundless sea. In the great current of the cosmos, motion is not merely something that happens within space-time, it is the act by which space-time exists. Geometry, curvature, and even the sense of distance are born from the restless movement of information through the quantum fabric. The universe, in its totality, is a self-sustaining flow, a river that generates its own banks, a current that sculpts the channel it moves through. Gravity, in this picture, is not a force acting upon space, but the natural curvature created by the motion of entanglement itself. The idea is subtle but transformative. When information flows through a network of quantum connections, it does not move randomly. It follows gradients, regions of imbalance, where correlations are stronger in some directions than others. The flow acts to even out those gradients, redistributing entanglement until equilibrium is restored. In doing so, the structure of space-time adjusts. The geometry stretches, curves, and twists so that the information can move most efficiently. The bending of space is therefore not a reaction to mass or energy, but to information flow. This view changes how we interpret the famous equivalence between mass and energy. If energy is the ability to do work, and work is the rearrangement of information, then mass becomes a measure of informational density, the amount of entanglement compressed into a region. A star curves space-time, not because it exerts a mysterious force, but because its interior is a storm of information, its particles continuously exchanging correlations at unimaginable rates. The curvature around it is the trace of that storm, the geometry shaped by its entanglement flow. This concept finds resonance in the physics of black holes, where gravity and information become inseparable. A black hole is not a place where matter disappears, but where the flow of information becomes so intense that it forms a horizon, a surface beyond which the correlations cannot be retrieved. Yet even there, the fluidity persists. The horizon itself behaves like a membrane, rippling and vibrating as information diffuses across it. The heat and radiation emitted by the black hole are not random noise, but the gentle leakage of the entanglement current, restoring balance to the greater universe. Physicists have found that the behavior of this horizon is governed by the same mathematics that describes fluids, the Navier-Stokes equations, reinterpreted in a gravitational setting. The event horizon has viscosity, temperature, and entropy density, and these quantities follow universal ratios. The holographic principle ensures that every detail of the black hole's interior, its energy, pressure, and motion, is perfectly mirrored in the fluid-like dynamics of its boundary. The black hole, far from being a void, is a whirlpool in the ocean of spacetime. When we extend this reasoning to the universe as a whole, a breathtaking picture emerges. The cosmic web, the vast network of galaxies and dark matter that spans billions of light years, behaves like the pattern of eddies on the surface of an enormous fluid. Matter flows along filaments, clusters form at intersections, and voids expand like bubbles between currents. These structures are not random. They reflect the deeper flow of entanglement that underlies all existence. The universe's expansion, its shape, and its fate are expressions of the hydrodynamics of information. At the heart of this vision lies a new form of unity. Every force, every field, every particle, and every bit of space-time is part of a single process, the diffusion and conservation of information. When quantum fields fluctuate, when gravity bends, when light travels, all are manifestations of the same current moving through different domains. The laws of physics are not separate rules, but harmonics within one great equation, the equation of flow. This hydrodynamic interpretation also explains why the universe evolves toward complexity rather than simplicity. As information flows, it tends to create patterns, vortices, waves, and resonances that persist even as the current moves on. These stable configurations become matter, stars, and galaxies. Complexity, far from being an anomaly, is the natural consequence of turbulence in the sea of entanglement. Every atom, every cell, every thought is a whirlpool of stability amid the greater flux. The notion that spacetime is a fluid of entanglement also gives new meaning to the cosmic horizon, the boundary of the observable universe. Beyond it, information continues to flow, but its correlations no longer reach us. The horizon, like the surface of a black hole, encodes everything within, ensuring that the total information of the cosmos remains conserved. What we perceive as the edge of visibility is merely the limit of our participation in the universal current. The cosmos extends beyond not as distance, but as unshared entanglement. In the smallest scales, near the Planck length, the fluid of spacetime may become turbulent. Quantum fluctuations twist and fold upon themselves, creating vortices of extreme curvature, miniature black holes that blink in and out of existence. Here, the distinction between geometry and information breaks down entirely. There is no longer space or time, only the motion of entanglement in its purest form, a storm of creation where the universe continually rewrites itself. From that storm arises everything we see: the calm expanse of space, the flow of time, the order of stars and galaxies. The great silence between the stars is not emptiness, but balance, the smooth, steady region of the cosmic current where the fluid of entanglement flows evenly. Every motion, every sound, every flicker of light is a ripple on that boundless surface. In this picture, the universe is not a thing that exists, but an action that continues. Its persistence is not a miracle of stability, but a consequence of flow. It does not endure because it is solid, but because it moves. The hydrodynamics of entanglement is the universe's heartbeat, the ceaseless rhythm that turns information into structure, chaos into coherence, and possibility into presence. As we learn to read this rhythm, we may find that the laws of physics are not boundaries, but melodies, patterns in the great song of existence. The galaxies swirl to the same tempo as atoms vibrate, and the pulse of space-time echoes in every human breath. Beneath all things flows one current, endless and indivisible, the fluid of entanglement that carries the universe within itself. They are the darkest and brightest things in the universe. To the eye, they swallow all light, but to the mind, they illuminate the deepest laws of reality. Black holes are not voids, they are vortices, places where the flow of information reaches its most perfect form. In their silence lies the key to understanding how space-time behaves when entanglement becomes absolute. Every black hole is a living equation, a natural laboratory where gravity, thermodynamics, and quantum mechanics meet and speak the same language. A black hole begins when matter collapses beyond its ability to resist its own gravity. The collapse continues until the density becomes so immense that space-time folds inward upon itself. The surface that forms, the event horizon, is not a physical wall, but a boundary in information flow. It marks the point beyond which signals can no longer reach the outside universe. To an observer, it is the edge of knowledge, a horizon where information ceases to return. Yet paradoxically, it is also the richest surface in the cosmos, for it encodes everything that has ever fallen within. The great insight of Stephen Hawking and Jacob Bekenstein was that black holes have temperature and entropy. The event horizon, though it seems frozen, glows faintly with what is now called Hawking radiation. This glow is not ordinary light, but the trembling of space-time itself, a whisper of quantum entanglement across the horizon. Each pair of entangled particles forms just outside the boundary. One escapes, the other falls in, leaving behind a subtle imbalance that appears as heat. From this process, we learn that a black hole is not an eternal prison, but a thermodynamic system, radiating energy and information back into the cosmos. Its entropy, a measure of the information hidden within, is proportional not to its volume, as one might expect, but to the area of its event horizon. This relationship reveals the universe's preference for surfaces over volumes, echoing the holographic principle. The black hole's horizon acts as a two-dimensional screen upon which all the information of its three-dimensional interior is written. Every vibration, every collision, every quantum state is recorded in the geometry of that surface. The larger the area, the more information it can contain. Yet the most extraordinary discovery is that the dynamics of this surface obey the same equations as a viscous fluid. When physicists perturb the horizon, when they imagine small waves moving across it, those waves behave exactly like ripples in a liquid membrane. The event horizon flows. It has viscosity, conductivity, and even a kind of elasticity. The equations that describe its motion are mathematically identical to the Navier-Stokes equations that govern fluids. In this way, the black hole reveals that gravity itself is a hydrodynamic phenomenon, the motion of information flowing through spacetime's fabric. The black hole's fluid nature is also reflected in how it processes information. When matter falls in, its quantum correlations mix rapidly with those of everything else already inside. This process, known as scrambling, is the fastest mixing allowed by the laws of physics. No other system in the universe thermalizes information more efficiently. Black holes are the perfect fluids of information, systems that reach equilibrium in the shortest possible time. This perfection is not a coincidence. It is a sign that they represent the most extreme expression of the universe's hydrodynamic principle. The ratio of a black hole's shear viscosity to its entropy density is 1 divided by 4 times pi, a value found to be the lowest possible for any known fluid. Remarkably, when physicists created the quark gluon plasma, the hot, dense state of matter thought to have filled the early universe, they measured the same ratio, The smallest droplets of plasma and the largest black holes share identical hydrodynamic behavior. Across a gulf of scale and time, the universe speaks in one voice. This unity goes deeper still. The equations of black hole dynamics are not separate from Einstein's equations of gravity. They are those equations, interpreted thermodynamically. The change in a black hole's area corresponds to the change in its entropy. The energy that crosses its horizon corresponds to heat. Even the force of gravity itself can be seen as a kind of pressure in the fluid of spacetime. When the geometry bends, it is responding to the same balance that governs the flow of air, water, and plasma. The cosmos, at its core, behaves like a single, self-regulating medium. There is a poetic symmetry in this. The black hole, long feared as the ultimate destroyer, turns out to be the most eloquent teacher of creation. It shows us that the universe does not lose information, it only transforms it. The matter that falls in is not erased but re-encoded, diffused through the horizon and released slowly over eons as radiation. The black hole's evaporation is the universe restoring balance, the slow diffusion of entanglement back into the cosmic sea. Nothing is truly lost, only translated. Even the structure of the black hole interior, though hidden from observation, may not be singular. Some physicists propose that it is a region of high entanglement density, where spacetime becomes so fluid that the distinction between inside and outside dissolves. In this view, the singularity is not a point of destruction but a phase transition, the place where geometry melts entirely into information. The interior of a black hole would then be the purest form of the universe's essence. Motion without shape, flow without limit. This idea aligns with holography. The interior of the black hole can be reconstructed entirely from information on the horizon. Just as a three-dimensional hologram can be projected from a two-dimensional surface, the entire space-time within a black hole is encoded on its boundary. In this sense, every black hole is a miniature cosmos, a universe in itself, governed by the same laws that guide the whole. The outer universe and the interior are reflections across an informational mirror. As black holes age and evaporate, they give back what they have taken, though in a transformed form. The final stages of evaporation remain mysterious, the whisper between quantum mechanics and gravity that no one has yet fully decoded. But the trend is clear. Information flows outward, rejoining the universal current. The death of a black hole is not an end, but a reintegration. The completion of an informational cycle that mirrors the birth and decay of stars, galaxies, and perhaps even universes. In the grand view, black holes are not anomalies, but archetypes. They embody the universe's most fundamental behavior, the tendency to turn chaos into equilibrium through the flow of information. They are the perfect exemplars of the hydrodynamics of entanglement, pure, elegant, and unyielding. When we study them, we are not peering into the unknown. We are watching the universe reflect on itself, expressing its deepest logic in the simplest possible form. Perhaps then, the greatest truth of black holes is not that they consume everything, but that they remind us everything belongs to the same flow. Light, matter, space, and time all are drawn into their orbit, mixed, transformed, and released again into the endless circulation of meaning. They are the universe's own breath, the inhalation and exhalation of reality. And through them, we begin to glimpse what the cosmos truly is, not a collection of things, but a living current of information, endlessly folding and unfolding, always returning to balance. In the beginning, there was no light, no form, no distance, only a sea of energy, unbroken and indivisible. The universe was a pure fluid of entanglement, a single quantum wave vibrating with infinite potential. In that primordial moment, space and time had not yet unfolded. There were no atoms, no stars, no galaxies, only correlations, endlessly interacting, each one tied to all others in perfect symmetry. It was not emptiness, but fullness, a dense ocean of information, perfectly balanced, yet on the edge of transformation. Then came expansion, not an explosion in space, but the birth of space itself. What we call the Big Bang was the moment the quantum fluid began to flow. The entangled ocean stretched outward, cooling as it expanded, and in that cooling, patterns began to form. Ripples of entanglement turned into ripples of energy, and energy into matter. The universe was not created from nothing. It was created from imbalance, the gentle breaking of perfect symmetry that allowed flow to begin. In those first instants, time did not yet behave as it does now. It was not a steady rhythm, but a cascade, the rapid unfolding of correlations as the cosmic fluid found its path toward equilibrium. The temperature of the universe was unimaginably high, trillions of degrees, yet it was also astonishingly smooth. Every region was connected to every other, sharing information so completely that differences could not yet exist. Entanglement linked the entire cosmos into one unified whole, like waves in a single boundless ocean. As the universe expanded, that perfect balance began to stretch and strain. Quantum fluctuations, minute differences in the density of entanglement, grew under the influence of cosmic inflation, a brief and extraordinary surge that expanded space faster than light could travel. These tiny irregularities were the seeds of everything that would later exist. The galaxies, the stars, even life itself, all began as whispers in the fluid of entanglement, faint ripples frozen into the structure of spacetime. The cosmic microwave background, the afterglow we now observe with radio telescopes, is the faint echo of those ripples. It is a snapshot of the universe when it was just 380,000 years old, still glowing with the heat of its own birth. The slight variations in temperature across that ancient light, only a few parts in 100,000, are the fossilized waves of quantum entanglement that once flowed freely through the young cosmos. Every point of light in that map is a record of the universe's first hydrodynamic motion. In those early ages, matter and radiation were inseparable. The cosmos was a plasma, a fluid of charged particles, photons and fields, all entangled together. It behaved not like a gas of separate elements, but like a single, shimmering entity, oscillating as one body. Pressure waves moved through it, the first cosmic sounds, resonating through the fluid of space itself. The equations that describe those waves are the same equations that describe waves in water or air, only written on a cosmic scale. The universe sang as it formed. As it continued to expand, the plasma cooled. Electrons and protons combined to form neutral atoms, allowing light to travel freely for the first time. The great ocean became transparent, and the photons released then are still traveling through the cosmos today, forming the background glow that fills the night sky. What we see as starlight is only a later echo of that first luminous breath. But even after the light decoupled, the flow of entanglement continued. The same quantum connections that governed the early plasma still stretch across the universe. When we observe distant galaxies, we are seeing not just their light, but the ancient patterns of correlation that once linked them to everything else. The large-scale structure of the universe, the vast filaments of galaxies and dark matter that weave the cosmic web, is the macroscopic trace of that early informational flow. The physics of the early universe mirrors the hydrodynamics of a black hole in reverse. In a black hole, information flows inward toward a horizon. In the early cosmos, information flowed outward, carried by the expansion of spacetime itself. Both are governed by the same thermodynamic principles: energy diffusing, entropy increasing, and equilibrium sought across a dynamic boundary. The Big Bang and the black hole are two sides of the same equation. One a collapse, the other an unfolding, both driven by the motion of entanglement. When we study the cosmic background and the distribution of galaxies, we are reading the universe's memory of that flow. The ripples frozen into space are like the ripples on the surface of a once boiling ocean, preserved long after the waters have cooled. Each fluctuation, each filament, each cluster is a remnant of motion, an imprint of information rearranging itself on the grandest scale imaginable. Even today, the universe carries that motion within it. The cosmic expansion continues. The dark energy that accelerates it, perhaps another manifestation of the same underlying fluid dynamics. The pressure of entanglement balancing itself across the cosmic horizon. The vacuum energy that drives expansion is not emptiness, but latent connectivity. The potential for information to continue flowing, forever seeking symmetry. In this light, the early universe was not chaos giving rise to order, but perfect order learning to breathe. The entanglement that once linked all things has never vanished. It has only stretched and diversified. Every star, every planet, every living being is part of that same current, a localized expression of the universal flow that began at the dawn of time. The sea of entanglement that filled the young cosmos still fills it now. It flows through atoms and galaxies alike, through gravity and light, through thought and motion. The universe has not stopped expanding because it has not stopped flowing. It is the same ocean, moving ever outward, its waves shaping the geometry of everything that exists. And in that motion, we can see the deepest unity of all. That creation was never a single event, but an ongoing process. The Big Bang was not the beginning of time, but the first great surge in an eternal current. The universe did not emerge into space, it became space. The fluid of entanglement did not fill the cosmos. It is the cosmos, endlessly unfolding, endlessly remembering, endlessly becoming. In the deep silence between galaxies, where light has traveled for billions of years, the universe still moves. Not in matter, not in air, but in the invisible flow of information. Spacetime, once thought to be a static background, is alive with motion. Every particle, every field, every curve of geometry participates in an endless circulation of meaning. The cosmos is not a structure, it is a computation, an unfolding algorithm of connection where each moment arises from the rearrangement of correlations between all others. Modern physics has begun to map this hidden current. The great quest of the 21st century, to unify gravity with quantum mechanics, has revealed that the key lies not in forces or particles, but in information. When scientists describe quantum fields, they describe how information is stored and transmitted between regions of space. When they describe gravity, they describe how geometry responds to those flows. The two are no longer separate domains, but expressions of a single principle. The hydrodynamics of entanglement, the universal motion that turns information into form. One of the most powerful tools for exploring this principle is the tensor network, a mathematical lattice used to model how quantum systems entangle. Each node represents a quantum state, and each link represents the information shared between states. When these networks are arranged in particular patterns, they naturally produce shapes that resemble the geometry of space-time. The deeper one moves into the network, the deeper one moves into the bulk of a holographic universe. The structure of the network defines the curvature of the simulated space. In this way, physicists have begun to build miniature universes from pure information. In these holographic simulations, geometry emerges as the large-scale image of informational flow. Where connections are dense, the simulated space curves inward, like gravity drawing matter together. Where connections thin, space stretches outward. These models show that Einstein's field equations, the laws that describe how matter and energy curve space-time, can arise naturally from the statistical behavior of entangled quantum states. Gravity is not imposed on the universe. It is generated by the way information organizes itself. Some researchers call this picture quantum circuit cosmology, the idea that the entire universe evolves like a vast quantum computation. Each moment of time corresponds to a new layer in the circuit, where the previous state feeds into the next through the flow of entanglement. The Big Bang was the initialization of this computation, the moment the first quantum operations began. Every galaxy, every atom, and every mind is part of that unfolding program. Each line of code written in the language of correlation. The hydrodynamic nature of this process ensures that the computation does not proceed in discrete jumps, but as a continuous flow. The universe evolves smoothly because information does not teleport. It diffuses. Entanglement spreads like heat, following gradients, redistributing itself until balance is reached. This is why the laws of thermodynamics, developed to describe steam engines and rivers, apply so perfectly to the universe as a whole. The cosmos is the ultimate engine of information, always exchanging, never resting. Even black holes, those perfect fluids of information, fit seamlessly into this computational view. When they evaporate, they do not erase data, but transfer it into new configurations encoded in their radiation. The process is unitary, reversible, ensuring that the total information of the universe remains constant. The apparent randomness of Hawking radiation is not loss, but transformation, the re-expression of information in a different form. The cosmos conserves not only energy and momentum, but meaning itself. At the frontier of quantum gravity research, scientists are discovering that space-time behaves exactly like a fluid governed by equations of conservation. The energy-momentum tensor, which describes how matter and radiation move through space, can be rewritten as a statement about the flow of quantum information. The geometry of the universe evolves to maintain that flow's equilibrium. When pressure builds, space curves. When density drops, space expands. The same logic that guides rivers down mountains guides galaxies across the void. This unity gives rise to a startling vision that the universe is not made of matter, but of information currents. Every field, every wave, every vibration is a manifestation of the same underlying process, the motion of correlation. Photons are ripples in the electromagnetic flow. Gravitational waves are ripples in the geometric flow. Consciousness may be ripples in the biological flow of entanglement inside the brain. Across all scales, reality is the same thing expressed at different levels of informational complexity. The implications reach beyond physics. If the universe is an evolving computation, then its laws are not static commands, but dynamic rules that emerge from the flow itself. They may have changed over time, refined as the cosmic computation unfolded. The constants of nature could be self-adjusting parameters, chosen not by chance but by stability, the result of a universe learning through motion how to persist. The cosmos, in this sense, is not a fixed creation, but a self-tuning organism. The currents of space-time are visible even now. The cosmic microwave background, the distribution of galaxies, and the gravitational waves rippling through the void are all the signatures of information moving across scales. Each structure is a record of how the universe has computed itself. The past, present, and future are not separate chapters, but simultaneous layers in the same evolving code. At the smallest scales, near the Planck length, this computation becomes turbulent. Quantum fluctuations twist into loops of geometry, forming temporary wormholes, bridges where information shortcuts across space-time. These microscopic vortices may connect distant regions of the cosmos, allowing the fluid of entanglement to circulate globally. Space itself could be the product of such circulation, its continuity maintained by the perpetual exchange of quantum information. If this is true, then the universe does not merely contain information, it is information in motion. Every atom is a computation. Every interaction is a message. Every moment is the result of countless informational flows converging, diverging, and recombining in a cosmic network too vast to imagine. The hydrodynamics of space-time is the syntax of this universal language, the grammar by which the cosmos writes itself into existence. And in that realization lies something profound. The universe is not random, it is self-expressive. The same logic that governs the flow of electrons in a circuit governs the birth of stars and the thought of a mind. Entanglement is the thread that stitches all things together, ensuring that even in the coldest emptiness, the current never stops. Space-time hums softly with its own rhythm, the whisper of a computation that began long ago and continues still, without beginning or end. The universe breathes, not in the way a creature breathes, but in the way a current swells and subsides, in the rhythm of flow and balance that defines all things. From the smallest quantum flicker to the sweep of galaxies across the cosmic web, everything moves as one continuous fluid of information. Matter, light, and gravity are the visible ripples. Entanglement is the hidden tide beneath them. What we call the cosmos is not a structure, but an organism, a living flow of connectivity that creates itself through motion. At every scale, the same principle repeats. Information seeks equilibrium. When imbalance arises, when density or curvature shifts, the flow adjusts to restore harmony. This universal reflex gives birth to the laws of physics. The conservation of energy, the expansion of space, the curvature of gravity, all are expressions of the same imperative. The universe maintains itself through the perpetual rearrangement of information. It does not sit in stillness. It dances endlessly. In this living ocean, space-time is the body, and entanglement is the pulse. When energy concentrates, the current folds inward, forming stars or black holes. When it disperses, galaxies drift apart. The entire cosmos breathes in these cycles of compression and release. The speed of light is the heartbeat, the steady tempo at which information can flow through the fabric. Beyond that rhythm, causality itself breaks, for the current cannot move faster than its own pulse. The geometry of the universe is sculpted by these flows. Every curve in space-time is a trace of the motion of entanglement. Every gravitational wave, a tremor in its living body. The same equations that describe the motion of water describe the bending of the cosmos. Pressure, viscosity, turbulence. These are not metaphors, but real properties of the informational medium that forms existence. The Navier-Stokes equations of fluids and the Einstein equations of gravity are twin expressions of one law, that motion and connection are inseparable. In this view, creation never ended. The Big Bang was not a singular event, but the first breath of an ongoing process. The universe continues to unfold as information flows outward, forming ever more intricate patterns of entanglement. Galaxies are eddies in that flow, stars are vortices, and life itself is a self-replicating wave, a localized pattern that learns to sustain itself by channeling information through matter. Evolution is not merely biological. It is the continuation of the universe's drive toward complexity through efficient information flow. This idea dissolves the ancient boundary between physics and life. The same principle that governs the curvature of space-time governs metabolism, thought, and awareness. A living being is not separate from the cosmos, but a direct expression of its fluid dynamics. The brain, with its billions of neurons exchanging electrical and chemical signals, behaves as a miniature holographic network, an internal space-time where entanglement manifests as consciousness. The act of thinking is a localized turbulence in the universal current, a wave that briefly knows it is a wave. When we look at the universe this way, purpose and meaning arise naturally. The cosmos does not need external design. Its structure and persistence are born from the intrinsic logic of flow. It evolves because motion demands continuity, because connection seeks expression. Every structure, every law, every being is a note in a vast, self-sustaining symphony. Even entropy, the slow diffusion of order into disorder, is part of that music, the expansion of complexity into deeper harmony. The universe does not decay, it matures. The holographic principle reinforces this living view. Every region of space encodes the information of its boundary, and every boundary in turn reflects the whole. Nothing exists in isolation. The part contains the memory of the total, just as a single drop of water holds the vibration of the ocean. Reality is recursive, self-reflective, and complete at every scale. The stars and the spaces between them, the observer and the observed, all are aspects of one continuous fluid thinking itself into being. If we could step outside the universe, we would see no objects or lines, no void or edge, only motion. A shimmering continuum of flow, endlessly folding and unfolding, each layer birthing the next. But there is no outside. We are inside the current, made of the same correlations we study, woven into the same geometry we attempt to measure. To know the universe is not to stand apart from it, but to feel the flow from within, to recognize that our own awareness is the universe looking inward, reflecting on its own movement. From this perspective, the great mysteries of existence begin to soften. Gravity is no longer a force, but a tendency toward informational balance. Time is no longer a river we drift along, but the rhythm by which the universe rewrites itself. Space is no longer a container, but the shape of connection. And death, whether of a star, a world, or a life, is not annihilation, but transformation. The return of structure to flow, of form to fluid. This realization brings us full circle. The hydrodynamics of entanglement is not merely a theory, it is a way of seeing. It reveals that beneath every phenomenon lies motion, and beneath motion lies meaning. The cosmos is a conversation between all that exists, a constant negotiation between entropy and order, chaos and coherence. Every atom, every mind, every galaxy participates in that dialogue. We have searched for the fundamental building blocks of reality and found instead a fundamental motion. The equations of quantum fields, the geometry of relativity, the thermodynamics of black holes, all are variations of the same truth. The universe is a flow of information balancing itself through time. Nothing stands still, and nothing is ever truly lost. The current carries all things, reshapes them, and gives them back in new forms. Beneath every star, every atom, and every thought, the same current moves, silent, endless, and alive. It is the motion that binds galaxies, the rhythm that drives time, the pulse that gives rise to consciousness. The universe is not built but continually becoming, its very existence sustained by the flow of entanglement weaving geometry, energy, and thought into one seamless whole. And so, as the great current continues, the cosmos writes and rewrites itself, forever folding meaning into motion. The hydrodynamics of entanglement is its breath, the eternal flow through which information becomes reality, and reality becomes aware.